What is Linux? Well, Linux is the kernel that powers the Linux operating system. Okay, that's kind of nice. And kernels are programs that talk directly to the hardware and manage resources and processes. So what does that mean? Well, in a CPU, your chip that runs your computer, ever since the 386 processors, we've had this separation. You have the kernel process, and then you have everything else is in user land, and they're separate. So the way to make security work was they decided to separate them and decided that only one program was allowed to talk to the hard drive, talk to the RAM, talk to all the other physical devices, and that program was then responsible for making sure other programs started up and gave them permission to access things. So the Linux kernel does that in the Linux operating system. It's the only program allowed to talk to the hardware directly. Everything else has to talk to the Linux kernel through things called system calls. Kernels need a whole operating system to be useful. There are different kinds of operating systems. If you look at Linux, you'll see that there are the GNU Linux operating systems, which is basically the GNU software mixed with the Linux kernel. You also find things like Android. Android is the Linux kernel put on top of, well, added to a bunch of other software to run a phone. When a Linux kernel is bundled with operating system software and shipped together, that is called a Linux distribution. In the Linux family or Linux world, there are many different families of distributions. You have the Red Hat family, you have the Debian family, you have all these source code distributions, and then there's this whole recent debate about changing init to systemd. Most distributions have switched to systemd, but some are still back on the old init system. So what's the Red Hat family? Well, the Red Hat family is one of the earliest families of Linux distributions. The Red Hat people discovered there was a problem. And that problem was, how do you package and ship software? And not just ship it, but ship it in such a way that you know which version of software you have and you can install things and make sure that they work together. And so the Red Hat company created this Red Hat package management software. And what happens here is all of your packages come as these RPM files. And these RPM files are then installed, and there is a database that keeps track of which ones are installed, and then each RPM can tell you what its dependencies are. It's become more advanced now. You have big repositories that keep track of lots of different things and keep track of what the dependencies are, so you don't have to try to figure that out on your own. The Debian family is basically the same thing as the Red Hat family. It's just slightly different, and that would be with the deb packages instead of the RPM packages. Slightly different focus. Red Hat tends to focus more on corporate company type things, and Debian's more the end user experience. Then you have these source code distributions. Well, these source code distributions, which includes things like I guess Slackware and Gentoo and Arch, these things, they try to ship something, but it wants to build stuff from source code, because if you build from source code, you have a much higher chance of things being compatible or not compatible and knowing very quickly. You also have situations where you want to optimize your system, and Red Hat and Debian, well, they're written with generic systems in mind, and they're not really optimized for anything. So it's kind of hard to optimize a Red Hat or Debian system much. But source code can get you much more optimized. Of course, it can be much worse as well. And then there is this whole system. So once the kernel starts up, the next big thing is, how do you start up everything else? Well, you have this very first process after the kernel that runs, and init, the system 5 init, was something that came out of the old Unix world, and it runs these systems. It starts up your services, and it eventually brings you to your GUI or your command line and starts something up for you. Systemd was created because they realized there were a couple of issues within it. First of all, it did everything sequential, and you want to be able to do some things in a different order. Maybe you want to be able to start two things at the same time if they don't have any dependency relationship. And then they just changed the whole way of doing things so it's more closer together. Init is just very organized scripts that do things, and systemd is a more organized system of doing stuff. So some hardware considerations. When you are getting ready to install Linux, you need to know, can your machine boot the installation media? So that could be a CD-ROM, hard drive, it could be floppy, or it could be some kind of network-based thing. You have to decide, can you boot it? Because you have to be able to boot into something in order to do your installation. And you also need to know, how much hard drive space do you need? Normally, the earlier versions of Linux could get by with just a couple of, megs. Then it moved up to a couple of gigs. And now you're looking at right around 8 or so gigs, and it's going to probably grow and get bigger as you need more and more in order to run. How much RAM do you need? Well, in the early days, you only needed a couple of megabytes, but now, if you want a GUI, you have to have at least a gigabyte of RAM, and that's just kind of a minimum. You really want more than that. You want to know, will your video card work? One of the issues that originally plagued Linux was these video cards would come out, but they had this whole thing about secret drivers. If you make a mistake with the hardware, all you have to do is just fix it in the driver and no one will know. But now, people do find out, because most of the video cards have source code that is available to look at, and people can see, oh, you messed up. The same kind of thing happens with the wireless cards, because if you have wireless cards, you want to have drivers. Linux likes to run with everything compiled from source code rather than just binary drivers. You also need to look at your other hardware needs. Do you need to have scanners or cameras or other devices hooked up? And do you have software for it? So you can look and try to figure out if the software is available and working for Linux. There are a couple of different installation methods. You can do a DVD installation. So this is typical for physical devices when you want to physically install it on a computer. Also, if you're using something like VirtualBox or VMware, you might use an ISO installation. You're actually doing a DVD installation, but the ISO image is really the image of the DVD before it's burned onto a DVD, and the virtualization software can pretend that the DVD is actually burned and install off of that image. You can do USB installations. You can do hard drive installations if it's already installed on the hard drive, and you can install from there. And sometimes you can do network installations, but that requires having some kind of a boot service and being able to install, off the network. Time and date. When you're doing your installation, you need to have your time and date set. So how does a computer clock work? Well, you've probably seen movies about crystals and stuff like that, and trekking through jungles trying to find amazing crystals that'll make things work great. And really the whole idea is you're just trying to find a clock, trying to make a clock work. And so they use quartz crystals. The idea is if you send electricity through quartz crystal, it oscillates at a given frequency, and the computer can count that and keep track of date and time. The problem is that not all quartz crystals are created equal, so it doesn't work that way. They get off a little bit. So in order to make things work properly, you have to use things like network time. So let's talk about time zones. Well, if everybody were in the same time zone, it wouldn't matter what time zone we were in. But if we were in different time zones, then there are all these differences. the question of, is it always the same number of minutes different between two different time zones? Well, that's not quite right, because you have things like daylight savings time and other things that mess everything up. Sometimes political changes change your time zones, and you want to make sure that you have the same time as somebody else. If you are in Seattle and someone else is in New York, well, there are a couple of time zones between you. And you want to make sure you have the same time, not the same time of the day, but knowing that you can take the time on your computer and calculate out what time it is in a different computer somewhere else. So it is important to make sure you set the correct time zone so that you know that you are not the same time as someone else. When you are storing your time on your computer, it gets written out into a chip, and the question is, do you want to store local time or UTC? UTC would be your Greenwich Mean Time or your Zulu time. So Windows machines tend to use local time for everything. Well, that's great until you move your computer from one time zone to another time zone, because then you have to sit there and recalculate everything. Linux likes to store everything as UTC. So then all it needs to know is what time zone am I in, and then when it reads it from the computer, it can immediately translate it into your time zone and be fine. Windows, when you move from one time zone to another time zone, you have to change it from your local time to UTC, then to the other time zone. Much more complex. Network time communicates over the network. You send a request to a server. The server sends you the time as UTC, and you have to calculate it and convert it to local time. When you're doing installation, you have to do your software selections. You have to decide which software should I select. Normally, the default is to have a minimal install. A minimal install has really minimal software. There's very little there. If you want to have a secure server, you want to start with a minimal install. However, if you want a desktop, you don't want to start with a minimal install. You want to start with something like the GNOME desktop option. So make sure you have the right one selected. What type of machine do you have? Well, that's back to your hardware questions. What hardware do you have? And you also need to decide, how is this machine going to be used? Are you using it as a desktop machine or as a server? Are you running it as a web server? So you want to try to pick what you want. If you are running it as a server and you don't want to be hacked, it's best to start with a minimal install. If you want to run it as a desktop, well, just start with a desktop. Can you install packages later? Yes, you can. You can install lots of packages later. Everything that you can do during installation, you can pretty much do later. And where does the software come from? Well, you have these software repositories, and your software comes from the repositories, and you download it and install it. And Linux, when you have these Linux distributions are, the main purpose of them is to provide these repositories so you can get your software later. What are the requirements of different packages? Well, fortunately, you don't have to know too much, but the repository does keep track of which software is required by which other software pieces. So when you do an installation of a particular piece of software, it will search through a database and figure out which dependencies are required, check your system to see which ones you already have, and then after it's decided which ones you have, it can download everything you're missing, install those, and then the package you need. So you don't need to worry too much. When you are doing your installation, you need to install Linux onto the hard drive. So where is that? Well, you have a hard drive, and you have it divided into individual partitions. So the hard drive can be different drive volumes, and Linux can be installed in any one of these volumes. Normally you'd want to install at least the bootloader, the main parts of it, on the beginning part of the hard drive, so that you can then read later parts of the hard drive and see everything. You also have this thing called swap partitions. A swap partition is used in situations where you run out of memory. If you run out of memory or hard drive space, really bad things happen to Linux machines. You don't want to ever run out of memory, ever. It's bad. Don't do it. So a swap partition is nice because it takes a portion of the hard drive and it uses it as virtual memory. So when you start running out of hard drive space, well, not out of RAM, you will take pieces of your RAM that are not being used, you'll write them to the hard drive, and if you suddenly need those pieces of RAM again, you will pull it from the hard drive back into RAM and put something else on the hard drive. If you do that a whole lot, that's called thrashing. It's really bad for your system. It makes everything slow because the hard drive is much slower than RAM. So you want to have swap, but you don't want to have a large swap. And you don't want to ever have to use the swap. You just want it there in case you do run into it. So what are the other partition types? Well, you've got these Linux types. You've got your swap. You also have things like RAID partitions or LVM partitions. So LVM is the local or logical volume management. The idea being that you can create a giant partition and then make other fake-ish partitions inside of it. LVMs make it possible to resize and move data around seamlessly. So it's kind of nice to have LVM. But if you aren't making huge changes or adding hard drives, removing hard drives, or if you're using a virtual machine, there's really no need to have LVM. You can just stick with your standard Linux partitions. Once you have a partition, you need to install a file system into that partition. And there are different file systems. Linux came from the Minix world, and so you have this Minix file system. And then you have expansions. So it was extended. The first extension of Minix was ext2, and then you have ext3 and ext4, and these are extensions for the Minix file system. But there are other different file systems. You can have XFS, which is the default on a lot of newer Linux machines. You also have Windows partition types like FAT32, and you have your NTFS. And Linux can create different file systems and put them into partitions and use them. And the way it uses them is through mount points. A mount point is a directory in your directory structure. So you first have your first main partition, which is your root partition for the entire system, and then you'll have directories inside of that. And then you can take any one of those directories in there and say, oh, this directory is going to be redirecting to a different partition. And those redirections into a different partition, where you merge two different partitions together into the same directory tree, are called mount points. On Windows machines, you have your mount points as drive letters normally. So you have the C drive and the D drive and the E drive and the F drive, and those would all be separate partitions. Networking. Why should I set a host name? Well, your machine does much better if it has a host name. Everything seems to work better. Usually, it even works much better if the host name maps up to an actual DNS entry in a DNS server somewhere. But that isn't required. And if you have a host name on your machine, that doesn't mean that anybody else can see that host name. Maybe they have no idea what you've set, and you're not telling them what your host name is. So it's mostly for internal functioning and making sure you don't have to use the host name of localhost. Why should I turn on my networking? Well, you can't do software updates if you don't have networking. It's hard to do any networking-based things if you don't have networking. So really, you should turn it on. But when you turn it on, what should you use? Should you use DHCP or a manual configuration? Most computers out there on the internet use DHCP. Most servers actually use a manual configuration. So if you're using a client machine, you're going to use DHCP. in most cases, and you'll use a manual configuration for anytime you need a server. There are some servers that will not run with DHCP. DNS servers really want manual configurations. DHCP servers want manual configurations. Active Directory and things like that on Windows machines want manual configurations and don't really run well on DHCP. Can I change the networking after installation? Of course. Linux networking on these CentOS Linux-based machines tends to be managed by the NM or network management tools, and you can usually click on applets in your GUI to change your networking settings, or you can use the NMTUI command from the command line to change your networking. Root. What is the root user? Well, the root user is the main user that runs the entire system. Root is the process or the user that runs all kinds of stuff and makes everything work. So, is it the same as administrative account? Well, not quite. Administrative users usually have a group that they're part of, and on most Linux machines, it's the wheel group. So, if you are a member of the wheel group, then you're considered a administrative user. And then the idea is that you can sometimes run administrative commands using different software, things like the sudo command, in order to run them as the root user. So what are the requirements for root password? Well, you really don't have a lot of requirements. During installation, it might throw a fit if you are having simple, easy passwords, but you want to have a password that's hard to guess and that you can remember. So you need to remember the password and don't forget it. But why is it set during installation? Well, it's a lot harder to set it after you've installed, after you've booted up, when you're trying to log in. So make sure you set it during installation. Additional users. Why should I create additional users? Well, it is not usually good practice to run as the root user all the time. When you're doing administrative tasks, you want to be able to have root access, but you don't want to accidentally click on some link and do something accidentally and have your entire system destroyed because you're running as the root user. So you want to run as a different user, and in order to run as a different user, you need to create an additional user that is not the root user. You can make it an administrative account, which basically puts it in the wheel group and allows you to run the sudo command, sudo. And that allows you to run stuff as root. So you want to make sure you have a good username, and a good username is a username that is not one of these standard easily guessed usernames. So standardly easy guess usernames would be your generic names, you know, your Alice, Bob, and Eve, those kinds of things. You don't want to have bad passwords either. Make sure the password is good and does not match the username in any way. Make sure it's complex enough to be not guessed easily. Once you do your installation and you boot up, you have this initial setup thing. And the initial setup shows up during the GUI installation. They want you to accept the license agreement, and then if you don't accept the license, then they kind of really don't want you using it, so they try to force you to do the license agreement. And then there's this whole thing about kdump. Kdump basically is a feature that allows you to have all of your memory written out to the hard drive in cases of a kernel crash. Usually you're not going to look at that, so you don't really care. But if you are a kernel developer, you might care about it and might want it there. Login options. What are the login options? Well, you can log in from your GUI, or you can log in from a command line. Normally, you start up in the GUI, and you just pass in your username and password, And usually your user shows up. You can just click on your user and then type in the password, and that's how you get in. If you don't want to log in as one of the users that shows up, you can select additional users, type in the root user's name, which is root, all lowercase, and the root password to get in the GUI. Or you can press something like Control Alt and F2, or Control Alt F3, or Control Alt F4, or one of those numbers, and drop to a command line, and then log in as root with a password. When you log in, you want to make sure that you realize that when you're typing your password, it will not echo back any stars or letters or anything like that. So you just have to know that the password is being typed in. Just trust that something's going in there. It makes it so it's harder to do some kind of a screen observing and stealing. So that's what that's for. So what might cause a login to fail? Well, you'll obviously fail to log in if you don't have that user on the system. You will fail if your password doesn't match the user's password. You will fail in some cases if you cannot log in because the hard drive is full or because directories got deleted. You might also fail to log in if somehow permissions got set incorrectly, if the ownership of a directory got messed up, if you break things, if your SE Linux context got messed up. So if you break things, it might not work. So how do you know if they're working? Well, if you log in, it's working. So then what can you do in your system? Well, you can do updates, you can install software, you can run the software. Those are really the things you want to do. All right, so when you're booting up, what is the boot process? Well, you have a bootloader. A bootloader is a piece of software that is there to load your operating system. Why do you need that? Well, originally, when they started looking at operating systems, they decided to start with these really small processes. They decided that the first 512 bytes of memory would get loaded into memory, and then you just start running it. Well, that's great, but 512 bytes is not very much for anything. You can't really run a huge operating system that. But you can load a program that loads your bootloader that then loads your operating system. So it's a long process with multiple steps. You have your BIOS load your first bit of the hard drive. That first bit of the hard drive loads your bootloader. Your bootloader then loads your operating system, and then your operating system then starts up your initial process, which would be init or systemd. The systemd process would then load up your services and load up your GUI and create all of your terminal logins and all of that. So it's a long multiple step process. How do you set boot options? Well, it depends on which options you want to set. But normally, when you're talking about boot options, you're looking at what the kernel loads as. And those can be configured in the grub configuration. And that's normally found in the etc boot directory. And sometimes that gets written out there from other directories. And you can look around for grub configurations and just find things. Where are the boot files located? Well, normally in the boot directory. And the boot directory contains your kernel, your initial RAM disk, mapping, your grub configurations. All those be stored in your boot directory. And I guess we already talked about how the system starts and when does the GUI start. But there you go. Navigation. So when you log in, where am I? Oh, where am I when I start? So normally you start right there in your home directory. And how do you move around? Well, in the GUI, you can click on things and look at different directories, and that will show you what's in them. If you get a terminal up or if you log in from a terminal, you will start in your home directory and you can use the cd command to change directories. Then you figure out, well, where is everything stored? Well, programs and user files and logs and configuration files are all stored in different places. The programs are usually stored in the /usr directory, but sometimes they're stored in the /opt directory, and sometimes they're stored in the /bin directory or /sbin. It depends on which programs you want. User files are usually stored in the home directory, so /home, and then your username. So you store all your files there. Logs get started in the /var directory, so /var/log. You can go in there and take a look around and see what you find. And then configuration files are normally stored in the /etc directory. So you can look at those and see what files can be edited and changed. When you're doing networking, it's kind of important to know what your IP address is, and you can type in ifconfig on most Linux and Unix-like systems, and that will tell you your IP address. So that's interface config ifconfig. However, on newer Linux machines, you need to type in IP space ADDR, and that will tell you your IP address. It also tells you your MAC address. Your hostname normally shows up in your prompt, but you can type in the keyword hostname by itself to see what your hostname is set to. Where is it set? It's normally set in the etc directory in a file called hostname. So /etc/hostname is where your hostname is normally set. Where is your DNS set? Well, there is the etc directory once again, because that's where the configuration files are at. There's an etc and then resolve.conf. Resolve.conf is spelled without a trailing E on resolve, so it's resolv.conf. And it is your name server that's set there. Where is the IP address set? Well, it is normally, it depends on how it's loaded, but the configuration scripts for the IP address are in the etc etc directory, and it's in the sysconfig network scripts directory. And there is usually a file called ifcfg dash and then your interface name. So ifcfg dash ens32 or ifcfg lo for the local loopback. And so you just go in there and look at that. How do you test your networking? You can use ping, traceroute. You can try to do stuff. How do you edit files? Well, you can view files with the cat command. Cat's actually from concatenate, but you can type in cat space and the name of a file and it will list the contents. You can look at them with the less command if you want to scroll through it. Make sure you press Q if you want to get out of less. Just less in the file name and Q to get out. But what about editing it? If you want to edit it, you can use VI, Nano, Emacs, gedit, any one of those editors. How do you get more editors? Well, you install them. You can use yum install and the name of the editor, assuming that's the name of the package that installs it. So which editors are best? Well, VI tends to be available on most systems. It's been around for a very long time, and many people who like archaic editors are familiar with VI. It is not the best editor. It is not a very good editor, and it's very cumbersome and complex, and people hate it. And because they hate it, they are starting to remove it. So it's starting to become less and less common on newer distributions, but it is pretty much installed on every Linux and Unix distribution out there right now. Nano is a much better one. Nano is based off of a original editor from the University of Washington called Pico. The University of Washington had bad licensing, so Nano was created as a drop-in replacement for Pico, and that's kind of nice. It's a much easier editor to use, not incredibly powerful, but it is easy to use. Emacs is one of the earlier editors as well, like VI. There was a long time a VI Emacs debate on which one was better. Emacs was written by the same people who wrote the GNU project, so comes from there. Emacs is very difficult to use, and I recommend against using it. Fortunately, it is not installed on Linux distributions by default, so you don't have to worry. gedit is your editor that shows up in your GUI, so much easier to use. You can click on buttons like a save button and open button, and you can see everything. And so gedit is kind of nice there. Software updates. How do I update the system? Well, use the yum command. So you can do a yum update yum, first of all, because you want to make sure your updater is updated all the way. If you don't have a fully updated updater, then weird things can happen sometimes. You want to make sure you update the software of the entire system. You can just do a yum update, and that will update everything. If new programs are available, it will update anything that's new. You can also update new stuff with by just doing yum install any individual package, and again update or install new packages. How do I know if it's already installed? Well, you can try yum install something, and if it says it's already installed, then it's installed. You can also type in the RPM command and look at the RPM database directly. So you can do RPM -QA to list all of your packages, or just RPM -Q and the name of the package and see if it's installed. How do you uninstall it? Well, you can do yum remove and the package. You can also do the RPM package directly, RPM -E for erase, and then the package name. So what happens when you update GUI files while in the GUI? Well, that happens sometimes. If you do a full system update and you're in the GUI, sometimes the GUI gets updated. And as you might imagine, if you're in the middle of running a program and that program changes, sometimes you have to read parts of that program from memory, and sometimes you have to read parts of that program from the hard drive. And if it changes on the hard drive, and you can get an inconsistent state that crashes. So don't update your GUI from in the GUI. Drop down to the command line and do it from there. How do I connect to the internet? Well, with the network. But you also need to have your browsers. So Firefox and other browsers are great. If you want, you can even install Chrome or other browsers. They are available and can be installed. How do I get a remote terminal? Well, remote terminals are things like SSH. So you can use SSH, and it's already installed on your system by default. So you can type SSH space and the IP address of a machine to log into that machine. Sometimes you need to pass a username. I usually do SSH space username @ IP address to log into machines. How do I get a remote GUI? Well, that's a lot more complex. You can have your X11 GUI exported, and then you usually go from one Linux machine to another Linux machine, and you can start up things like terminals inside or web browsers inside of your local machine that are actually running on the remote machine. Or you can use something like VNC or other software to get a remote GUI. Capturing data. How do I take a screen print? Well, if you're running a virtual machine, that gets a little bit tricky. Sometimes the screen print button works for taking pictures, and sometimes the screen print button doesn't. If you want to take a screen print of something and you want to show what's going wrong when you're trying to talk to people, it's usually best if you're outside in a virtual machine to take a picture of the virtual machine's window using your local screen printing tools, such as the snipping tool on Windows. How do you get data from a terminal? Well, it depends on how you're connected. If you're connected to your virtual machine through your virtual machine's window. Maybe you can't. Maybe you can. Maybe you just select it and copy it. Sometimes it copies out, sometimes it doesn't. What's usually easiest is if you SSH into your virtual machine or SSH into your machine, it's easy to copy and paste into an SSH terminal emulator, and that makes it much easier. In addition to that, if you have a terminal emulator that allows you to do file copying, you can just usually drag and drop or copy it. Sometimes you use the SCP command to do a secure copy between machines as well. And then last, how do I get out of my GUI? Usually there is a button in the upper right hand corner, sometimes it's the lower right hand corner, sometimes it's the upper left hand corner, and sometimes it's the lower left hand corner. So you just have to figure out where it is, but click on the button and it will allow you to log out or shut down the machine. How do I log out of a text terminal? Just type the exit command until you are logged out. How do I shut down? Well, in the GUI, you just find the button to shut down. On the command line, you type in the shutdown command to shut down. Usually you have to tell it when you want to shut down, so type in shutdown and then the keyword now to shut down now. How do you reboot? Just type reboot on the command line, or from the GUI, find out where your button is. And this has been a quick little overview of your Linux installation and leaving Linux machine, using a Linux machine. So good luck. Command line navigation. When you first log in, you're in your user environment, and there are things you can do and things you might want to do, but you need to know how to do them. One of the things you want to do is probably bring up a terminal window. Many things, many different commands are written specifically to run well in the terminal, and if you don't have access to the terminal, it's hard to run them. Not everything is created to run in the GUI. So how do you bring up a terminal window? Well, let's look at this right here. You can see if I click on my application, then I can scroll down to favorites, and off to the right side there is terminal. You can also go down to utilities or system tools, and you can find your terminal down here. Either way, you can launch the terminal, and once you have the terminal up, you can start typing in commands, and that's pretty useful. So what do we have? Where am I? If I do a pwd command, I can see my present working directory. I'm in the /home/Joseph directory. If I do an ls command, I can see things that are in that directory. I can do an ls-l to list it in long format, which makes it easier to read for some people. Or I can do an ls-al to show all files, including the ones that are hidden. Hidden files are basically just files that start with a dot. I can see all these files in my directory. So let's go back to the slides. Directory I'm in. Well, the pwd command. What does my prompt tell me? Well, the prompt tells you your username, and it also tells you the directory you're in, and that can be useful. It also tells you the host name, and we'll look at that again when we go back to the terminal. When you're logged in, you have an environment. Well, what are environment variables? Environment variables are basically name value pairs that are stored that your programs can use. So if you look at your environment, you will see a bunch of name value pairs. One of those name value pairs would be something like username, and it would actually list the user. For in my case, it would be Joseph. So username equals Joseph. I might also have things like my path. A path is a list of directories that I look in whenever I type in a command to try to run that command. So it doesn't matter what my environment is? Well, it does, because if you have a environment and your environment doesn't have certain things in it, then you will have to explicitly indicate where those things are. Programs rely on the path to be able to find things. You can look at your environment with the env command to show the environment. You can also change them with the export command. So let's go ahead and look at this again. So if I type in env, I can see all these different variable sets, such as my home and my actual home directory, which can be useful because then I can use a program and I can tell it, instead of going to /home/Joseph, I could do something like use the home variable. So how to use the variables? Well, if I wanted to type in echo, I can type in echo and it will tell me things. It will repeat whatever I tell it to repeat, but I can use variables here. Echo home with a $sign, and it will not echo the word home, but it'll echo the value of the home environment variable. Some of these variables are set in some of the files in my directory. So if I do ls-al, I can see there is a .bash_history, .bash_logout, .bash_profile, and .bashrc. So if I take a look at the .bashrc file, you can see that it has information here. You can also see the keyword export is in the file, but there is a hash mark in front of it, meaning it is commented out. If I look at my .bash profile, .bash_profile, I can see another thing right here. I can see path is being set to whatever the path was currently at, but then it's adding stuff to the end of it, and then it is exporting it into the environment. So whenever I log into my system, this file, the .bash_profile file, will be executed. And you can see the cat command can be used to display contents of files. All right. Terminal redirection. When using the terminal, what do the greater than, less than, and double greater than mean? Well, greater than is used when I'm running a program to direct the output into a file. So whatever comes after that gradient, whatever is pointing to, is where it goes. The less than, I am directing a file's contents into the input of a program. And then the double greater than means that I'm taking the output and appending it to a file. I can also use variables in commands, and I can use backticks as well. So let's go back to this terminal and take a look at it. So if I type in something like time, it will display the time. If I type in date, it will display the date. What if I wanted to save the date? Well, I could type in date greater than saved date.txt, and it will save the date. If I go cat saved date, I can see the date's been saved. If I run it again, the same command, it will overwrite it and replace it. If I use the cat command, I can see the new contents of that saved date text file. If I use the double greater than, now it will append it to the end of there. I can append it multiple times, and then I can go look at the contents of the file, and I can see now we have multiple entries that are in this file. That can be useful. So what's the backtick? Well, the date command also has options you can use. So if I do date plus %d, it says 09. Well, that's because it is the 9th day of the month. I could also put in quotes right here, add some more things like a %Y, And now it adds the year. I do a %m, and it adds a month. And if I want, I can even add dashes in here. So now it displays that. So how can that be useful? Well, what if I want to save the date and I want to save it into a file? So I can do date, redirect that into a file that has whatever this thing produces, .txt. That's a little complex. So basically what I am doing is taking the date command, running that. It will produce a date in the format we saw above. And then this format above will be sent to the output. The output will then take this command and run it, and it will generate a date. It will then append a .txt to the end of that, and it will create a file with the contents there. So now I can do a cat and 2019-4-9.txt, and I can see the contents of that file. So that's what the backtick does. Takes whatever runs, whatever the output is, and puts it right there on the command line for you. Manual pages. How do I find information about commands? What command or what information is provided by manual pages? How do I find out, or how do I get out of this man command? And what if there are C functions and programs with the same name? Well, what if I want to know how to use that date command? I just used it, it worked. I can type in man date, and then it lists information about that command. I can use the up and down arrows to scroll through it. I can see, instead of using a %Y, I could use something else, like a %y, which would only give me 2 digits instead of 4 digits. If I want to get out of this, all I have to do is press the Q button. That's kind of nice. It's very useful in giving me information about commands. Also, if you want to, sometimes the command also shows up in programming languages. So if I type in man2 date, it looks to see if there's a section 2. Man3 date, is there a section 3? If I look at man time, you can see that there up here is there is a time 1, which means I'm looking at man page 1. Well, time happens to also be a C function, so I can do man2 time and see if it shows up there. And we can see, oh, this is a little bit different than the man1 time. This is man2 time, and now we're looking at C code. It tells me how the C code is used and what it does. Now, file management. How do I create files? How do I edit files? What information does the file system keep on each file? How do I move a file? How do I rename a file? How do I copy a file? How do I delete files? All of these things are kind of important things to do. So let's jump right back in there and see how we do them. Okay, you can create files, obviously, by redirecting output from something to another file. And you can see that I've created a few files. One of them is this date thing. If I do ls-l, I can list a bunch of directories and files, and maybe I want to get rid of that saved date, so I can do rm saved date, and that gets rid of the file. I can also rename files, so mv is either move or rename, so I can do mv 2019-04-09, and I can call it some file.txt, and that will either move it or rename it. Basically, moving and renaming are the same thing. The reason why we use the move command is because the way that we are moving something is by actually changing the entry in the file system that points to the data on the drive. So we're just changing that entry. And so that's the exact same process as moving something. So it made a little bit less sense to have two different commands. I can also create empty files. So look right here. There is, well, the sum file.txt. And if I want to create another file that's empty, I can do touch. What touch does is it touches the file, it changes the modify date times and things like that. So if I do touch new file.txt, it will change the date, the modification date of that file. Well, the file doesn't exist, so it creates it and then changes it. So if I do ls-l, you can see that a new file has been created, and there it is. You can also delete files. In addition to using the rm for remove, you can use the unlink command. So if I unlink new file, it takes away the symbolic link, or not symbolic, the hard link to the file, and then the file is gone. On the directory entries here, you can see this number 1, number 1 right here, and then the rest of them have 2s. That is the number of links pointing to that entry. And when the number of links goes to 0, the file is gone and the memory is released. Okay, so that's how you do some modifications and things like that. If I wanted to move the sum file into my desktop, I can move the sum file to my desktop. Now it is case sensitive, so lowercase desktop is not the same as uppercase desktop. So if I do it with a lowercase d, it says it's not a directory. If I do it with a capital D, it does say it's a directory, and suddenly it shows up on my desktop right here. And if I want to remove it, I can either remove it, well, by giving it the location of the file, or I can go into the directory, take a look around, see it's there, and remove it there. And then go back down to my directory I was just in. And that's how you can do some basic file manipulation. But what about editing files? Well, I can use nano new file.txt, and then I can type in some file contents, something, and I can press Control X to exit out. It asks me if I want to save it. I say yes, and asks me if I want to use the same name that I typed it in, and I just press enter, and then it creates a new file. And I can see this new file.txt. And I can use the cat command to display the contents of the file. All right. Searching and editing files. How do I find files containing some string of characters? How do I display the contents of a file? How do I know what type of file a file is? And how do I edit a file? Well, we just edited one, so we can see that. We know how to do that. But what about finding files that have contents? We know how to display the contents because we've used the cat command. So now let's go ahead and find files. I have a file in my directory somewhere that has the word something in it. We know which one it is. I can do a grep command, grep something and star to search all the files in my directory. Well, all the ones that don't start with a dot. And then it shows me, okay, a bunch of these things are directories. We can't search those, but there is this thing, new file.txt, that has the word something in it. And I can even use parts of that, smaller pieces. If I'm using the word some, I can see that something still has some in it and it still shows up. So that helps me find the file. If I wanted to search in other directories, let's say I move this new file up to my desktop, it's gone. If I do a search, nothing shows up. Now, if I want to search all of my directories for files inside of them, I can do a */*, and then it finds this something up there. Doesn't really tell me where it is though, which is kind of difficult, but it does give me an idea that it is existing somewhere. All right, so that's searching. How do I create directories? How do I move directories? How do I rename them? And how do I delete them? Directories are kind of like files. They're files that contain contents, including, well, files. If I do ls-l, I can see that I have a bunch of directories here. I can create a new directory with mkdir for make directory. So my new directory is going to be called new directory. And then I can use ls-l, and I can see that this new directory is there. I can rename that new directory mv neuter as older. And that changes it, ls-l. Now I have to be careful. If I decided I wanted to rename this old directory as desktop, what would happen? Well, if I do move older desktop, that directory already exists. So what it will actually do is it will move it onto the desktop. So you have to be careful with these removing or moving of directories. I can also remove that directory of rmdir desktop older. So it'll go up into the desktop directory and remove the older directory, but only if that older directory is empty. So if I drag this new file into the older directory and then try running it, it will say directory not empty. So I can go into that directory, or I can remove the file first. Desktop older new file. I can remove the old file or the new file, and then I can remove the directory. So you cannot remove directories using the rmdir command if they have contents in them. If I create a new directory, new again, and I create a file inside of it, touch neuter new file, I can't remove the directory with the rmdir command, neuter. However, I can remove it, neuter, with a recursive command, minus capital R, to recursively remove it. And that will remove the new directory and all the files inside of it. So it cleans it out and it's gone. So that is a little bit of directory management for you. Links. What are hard links? Well, hard links are entries in a file, usually a directory file, that tell you where the contents of a file are on the system. Symbolic links are like shortcuts. They tell you a location. And this is not a physical part of the drive where they're located. They tell you a directory and a path all the way to the file. So they are not quite the same thing as Windows shortcuts, but they're very similar. Windows shortcuts are files that contain all kinds of information, including the path. So how do I create links and symbolic links? We know how to remove them because we can use the unlink command, and as you might guess, you can also use the delete command or the rm command. So I'm going to create some links. So if I look at my directory, I have no files. So I do touch new file.txt, and now I see that there is a new file. It also has one hard link to that new file. So I can do ln new file and then new file 2.txt, and this creates a symbolic link, well, not symbolic, a hard link from new file to, well, the new file to new file 2. So if I do ls-l, I can see now there is the number 2 right here, indicates there are 2 hard links to the new file and new file 2. I can do ln -s for symbolic, new file, and I can create a new file 3.txt which is not the same thing as a hard link. So the number 2 will still stay at number 2, but you will see a new entry. And that is my symbolic link. The symbolic link has one link to it, and it points to new file. And so if I were to look at the contents of new file, which is empty, then, well, they'd all have the same thing. So let's go ahead and put something in it. So I echo hello, and I'm going to append that to new file.txt. Now if I do ls minus l, I can see that the content size of new file 2 and new file has both changed to 6, but new file 3 still has the same 11. Any one of them will display the same content. So new file.txt, new file 2, and new file 3 all display the same contents. But if I want to remove things, if I do an rm new file, well, what do I have here? Now we can see that new file 2 is still there. And new file 2, because it was pointing to the actual physical location on the hard drive, will still have contents. New file 3 was pointing to the name new file, so the contents will be gone. So cat new file 2, I can see the content still, and new file 3, well, it says, well, there is no new file, so I can't do that. So I'm going to remove that, new file 3, and remove new file 2. And they're gone now. And then absolute path versus relative path. Absolute path starts with the very root of the system, so it's the slash directory all the way down to the location of the file. Relative is based on where you're at. So all the symbolic links I was doing were relative paths. All the directory entries I was doing were relative paths, all based on where I was currently at. So they can be used interchangeably in certain situations. So let's go ahead and look at this. If I wanted to look at my current directory, I can do ls minus l space dot. Dot is my current directory, and I can see what's in my directory. Also, because I know which directory I'm in, I can use /home/Joseph. So ls minus l /home/Joseph will also display my current directory. But I could look at the /home directory and see other users. Well, there's nobody else, just me. Or I can look at the slash directory and I can see all of the directories on the system and get an idea of where things are. This is useful because using these absolute paths, even if you are in a different location, the absolute path always works. If you're in a different location, if I do ls minus l dot dot, it'll show me the home directory. But if I go down into my home directory and use the same command, it will show me the slash directory. But no matter where I am, ls minus l /home will still show me the home directory. Even if I move to the slash directory, it'll still show me this directory. If I want to go back to my home directory, I can type in cd /home/Joseph, or I can type in cd, or I can do cd tilde to get back to my home directory. Anyway, these are some of the things you can use for going around looking at directories. And that is the end of our slides for this chapter. File systems. In understanding the basics of file systems, one of the first questions that come up is understanding what is the purpose of a file system. A file system helps you organize your space. A hard disk is really a large set of bits that are organized by, well, into bytes and organized by addresses. And you can use the addresses to address anything on the entire hard disk. So you have this huge space with lots of addressable bytes. And then you have to decide, well, okay, if I want to store data on this, how can I store it? If you have a large, gigantic file, maybe your file is a 1 terabyte file, you can start from the very beginning of the drive and start writing the file out, and then at the end of the file, you'd have it all written there, and you could just read that single file back and you'd be fine. But sometimes you want to put more than one thing in there. So if you put 2 files in there, the question is, well, where does one file begin and the next one, well, where does one end and the next one begin? And you have to decide how to keep it organized. So a file system allows you to overlay a piece of information that contains all the addresses in that partition, and lets you keep track of where files are, what space is available, what permissions are set, which users have what permissions, and all the information that you can use to provide security and organization. So how much space does the disk really have? When you go in there and you look at your machine and you see how much space it has, is that the real amount? Well, not usually. Usually what you're seeing is how much space is available in the file system. So then how do you know which disks you have? Well, you can use some of the GUI tools, or you can use tools such as fdisk, which will allow you to see which disks you have, which partitions you have, and then even you can look in there and figure out things like how they are formatted and set up. So what is a partition table? Well, when you take your original disk and you decide to break it into individual pieces, there is a table, usually the very front of the disk, that will tell you where a partition begins and where it ends. Partitions are individual, well, blocks that we turn into volumes. And there are 2 main formats that are currently in use. There is the MBR, which is the master boot record, and then there is the GPT. GPT is, well, it's an acronym that contains an acronym. And the G is GUID, which is globally unique identifiers. And then PT is partition table. So GUID partition table. So MBR was written with the idea that machines would only go to 32 bits. And because of that, the addresses are only 32 bits, which means that your largest, you basically only address beginning and ending of partitions in 32-bit numbers. And if you know much about 32-bit numbers, that basically means you have 4 billion different possible addresses. And so that's how you would have to have your partitions set up, to be based on the idea there are only 4 billion addresses. You'll find that's quite a bit of a problem with 32-bit file systems, as well as the MBR, and it limits it quite a bit. With larger hard drives, in order to be able to address everything, you have GPT, which has much larger, well, addresses. And it also resolved quite a few smaller issues with MBR, such as the number of partitions you could create. MBR originally was limited. It didn't have things like extended partitions and logical partitions, and well, anyway, it was a mess. So GPT solved a lot of that. So then how do you edit the partition table? Well, you can use the fdisk command to edit it. And once you edit the partition table, you write it out. And what it does is it writes out to your, either MBR or GPT, and that information is stored there. But then the kernel doesn't know about it unless the kernel goes back in and rereads that information so it knows about it. So you can use things like partprobe or other utilities to tell the kernel that it needs to reread the partition tables and reload that information. And then it can start using that information as it mounts partitions and puts them into its setup. So what partition types are good? Well, at this point, it's probably a good idea to actually create some partitions so we can get some ideas of how it works. So let's jump into it. I have right here settings. My machine is currently turned off. I can go over to storage and click on my controller SATA. and then I want to add an extra disk. So I create a new disk, and this will be a nice virtual disk, dynamically allocated, and I can go with whatever size I want. Let's just go with a 1 gigabyte. It's a nice small disk, and I can keep new virtual disk, or I can just say spare. Doesn't really matter what I call it. I create it, and then it's ready to go. Once my machine boots up, I will be able to use that partition or use that disk and make partitions out of it. So I'll go ahead and start that. All right, I kind of skipped through the booting process. Now I am ready to log in. So I log in as root with my password aloha123, and I go into my machine. Now at this point, I have the option of either using command line utilities or the GUI. You want to probably get used to using command line tools because the GUI isn't always there. But let's look at the GUI. So I click on applications and go down to utilities, and I can see there's this disks option here. I created my old disk, and that one is 32 gigabytes, and then the new one is 1.1 gigabytes, and it's all unknown space. So I can also see the device name is dev/dev/sdb. The first one is /dev/sda, and I guess it's got multiple partitions in it, SDA1 and SDA2. In the SDA2, I can see that the partition type is Linux Volume Management, LVM, which means I can then create individual, volumes inside of that. The original one is a standard partition, and that one is where I have my kernel and other information stored. So I want to work with this second disk, and I can click on icons here and create stuff, or I can drop down to the command line to show you how that works. So go to the terminal. All right, so in order to build partitions, I can do fdisk -L to list all my partitions. It shows me I have a couple of different partitions. You can see there is a /dev/sda and a /dev/sdb. SDB is 1073 megabytes. So I will go edit that one. So I do fdisk /dev/sdb, and I can use my M key to show me my options. This will list all the commands I can use. P is to print my partition table, and I have no partitions. So I want to add a new partition. So I do N for new. I can decide what kind of partition it's going to be. And this one is going to be a primary partition. So P, partition number 1. And I can decide what my first sector is. I can just press enter here and decide how big this is. I have a full gigabyte to work with, so I will make this first one, let's make it 200 megabytes. So I can do plus 200 M. It creates the partition. I can then use P to print my partition table, and I can see the type is Linux. Linux works great if I want to make a file system. Other options I can also list with the L option. And you can see there are quite a few different partition types. And all of these partition types are listed in hexadecimal index values or type values. So Linux is 83. If I want to do swap, it's 82. I can also do things like LVM and other partitions as well. So LVM is 8E. I'm going to leave this as a standard Linux partition type. So I will do write W, and then I will be out. At this point, I can type in part probe, and it does not have the command. So I can install it, yum install part probe, and it has no package there. So we will just go ahead and assume it's there, and the kernel will just have to figure it out. So the kernel will try to read it. So to mount this, you first have to build a file system. So which file systems do I have? Well, there's the mkfs command If I run it by itself, it tells me that here are my options. But the nice thing is this is just a front end to the other commands. So I do mkfs tab tab, and you can see these are other commands that start with mkfs. So mkfs dot, and then you have different file systems. So let's go ahead and go back to the slides. All right. So which partition types are good? Well, you want to have Linux probably for most things. All right, what file systems are available on Linux? Well, we just looked at that. The mkfs command will show you which file systems are available on your system and which ones are installed there. You usually have a couple of different things to install. There is the programs or utilities type packages that go with things. So if I wanted XFS, which is already on here, there might be an XFS progs package, which would give me the XFS information. Some of these things require a kernel module to be loaded. Sometimes you have to do other things, but that usually provides the utilities you need in order to format the file system. So what is the difference between different file systems? Well, some file systems have features that other ones don't. For example, the FAT32 file system, which is very common in the older DOS and early Windows operating systems, has all kinds of features to allow you to create files and do things with the files, but it doesn't really have a lot with permissions. And in addition to not having permissions, it doesn't really have things like SE Linux or other security features that Linux has. It works great for cameras. It works great for computers that don't have multiple users, and that's really what it's good for. When you go to other file systems, such as ext3, that's what a Linux file system. ext3 is different from ext2 in that ext3 added journaling. Journaling is the ability to write to your file system and tell your file system what you're going to write before you write it. And then after you write it, you remove your entry. And this makes it in a state where you don't ever get to a place where you're in the middle of writing something and you have no idea if you've completed writing it, because you say you're going to write it, you write it, and then you remove the entry that says you're going to write it. And if you crash anywhere in the middle, then you can figure out where you're at. And you can back out of things if you can't get it completely done. ext4 has more features added. You have XFS, which also has journaling and other Linux type partitions, permissions, and other things like that. So which file systems are supported? Well, once again, you have this mkfs command, which will show you when you press tab twice which ones are available. You can install additional ones, and that's usually using the yum package management system to install other packages. Sometimes you'll have to go and make kernel modifications or get kernel packages as well, but most of these are packaged in a way that makes it pretty easy to get them. So, formatting. Why do file systems need to be formatted? Well, if you mark a partition you create as, well, you create this partition, it still is just a block of space. You have to decide how to put the file system in there, and the way you do that is through formatting. What formatting does is it starts writing the file system in the beginning and then puts in all the indications it needs through midpoints and other places in there so that you can, well, start doing stuff. So let's go ahead and create a file system. So I'll jump right in here. So I'm going to create this one as ext3. So mkfs ext3, and the question is, well, which partition is it? Well, we know the device was /dev/sdab, and it's the very first partition I created, so it's /dev/sdb1. So sdb db and I can see a 1 here. So now I type in this, and it will create an ext3 file system. And that was quick. But there are other options you can add in there as well if you wanted to, such as labels and different things like that. So now that it's formatted, I can start using it, but I have to figure out where I'm going to use it and how I'm going to do stuff with it. So let's go back to our slides. How can I change how a file system is formatted? Well, let's go back to this file system and let's change it. I don't really want ext3, so let's change it to ext2. Now it's ext2. Let's change it to ext3. It's ext3. Let's change it to xfs. Now it's not xfs yet. It says that it appears to contain an ext3 file system. Use the -f option to force an overwrite. So I do -f. And then it reformats it. So now it's xfs. And then I can change it back to ext3 or ext2. And convert it back. All right. What happens if there's data on the file system and I want to convert it? Well, you can actually modify it in place for some file system types. For example, going from ext2 to ext3, all you need to do is add a journal. So if I do tune to fs, I have the option to add a journal to the file system. So how do you do that? Well, it's with the -j option. So I do tune to fs -j dev /ext2, not ext2, sdb1. And now I've added a journal. So basically, I've now converted the ext2 file system into an ext3 file system without damaging any of the files on there. But there are no files. Not really. I mean, there's a empty directory for lost and found for if I lose things. But that's it. I could also do things like add a volume label. So I want to call this my maybe storage. It already has a journal, so I take that away, say fine. And I put this storage label on the partition. All right, on the file system. Now, if I want to use it, well, I just need to mount it. All right, let's go here. How do I know if a file system has been formatted? Well, sometimes you don't. The easiest way to figure it out is you try to mount the file system. If you try mounting it and it doesn't mount, usually that's an indication that it's not done correctly. It does some auto detection. That helps a lot. Trying to format over it usually tells you, if you're trying to go to something like xfs, it will tell you that it has something there, but you don't always know. So what is mounting then? Well, mounting is where you take part of your directory structure and you link in this new partition into that structure. So you have a directory and your directory can then be redirected to a new partition, a new file system, and you can start seeing things. So where are the file systems located when mounted? Well, the file systems are just integrated into this entire directory tree. You can use the mount command by itself to see which ones are currently mounted. You can also see what mounting options were used when mounting. Mounting options are things like mounting it as read-only or read-write. You can mount it with information about how fast you can write to it, which users are allowed to do things, lots of things. Can you mount uncommon things like DVDs? Well, DVDs aren't that uncommon, but yes, you can mount them. You can mount them as actual DVDs, or you can even mount the ISO images. So let's go ahead and mount this partition we just created and formatted. So I have to figure out where am I going to put this partition. So I call it storage. It's a /dev/sdb1. So let's make a directory and we will mount it there. So if I do mkdir, I can create a directory. So I'll do slash, and let's say new storage. Doesn't really matter what I call it. And then if I look at my file system, there is this directory called new storage. If I go into new storage, there's nothing there. So I go back out of it. So I'm at the root of the file system and I want to mount this new partition there. So I do mount, and I can tell it the mount device SDB1 and the mount partition or mount point. So new storage. So I do that command right here and it mounts it. If I go into this new storage directory, I can see there is a lost and found directory here. This lost and found directory is stored at the root of any ext type file system. So now I can see it's mounted, which is kind of great. Of course, if I reboot the system, it will no longer be mounted because I manually mounted it and it's not being automatically mounted. So that could be kind of a problem. So what is the file system table? Well, the file system table is a file on the file system that tells you where everything is mounted and how they're mounted. So I could actually have this directory automatically have my new partition mounted to it at boot time. So how do I edit this file system table? Well, use a nano or some other editor and you edit the /etc/fs tab file. Okay. Then we have to figure out if it's working and look at what happens if I mess up. So I was mounting the device SDB1 to new storage. So I'll do nano. I'll tell the etc fs tab. If I go in here, I can see these are the partitions that are mounted. So I'm going to add a new partition here. So you first start with the device. My device is /dev/sdb1. You have some space, it could be a space, a tab. I just put a tab. My mount point is new storage. Then I have to tell it what type it is. This is ext3. Give it the defaults. And then these numbers indicate things like backups and other stuff. Just put zeros here, you're fine. Exit out. Now there's this file. Because it's mounted, well, I should be able to use the mount command and see that it's mounted. And you can see at the very last line down here, there is an indication that this thing is mounted. I can see which options are in place. It's read write. I can see it's mounted to ext3, and I can unmount it with the umount command. Umount /dev/sdb1, or I can tell it the mount point. So I can unmount it that way, or I can remount it and unmount it with the mount point. Either way, it will get it unmounted. Then I can run the mount command by itself, and I can see that it is no longer mounted. Now, if I try running the mount command, mount dev sdb1, well, what happens? It mounts. And the reason it mounts is because it looks at this device and says, where is that device at? And then it finds the fs tab file and sees the device listed in there as the last entry, and it knows where to mount it. So I run this mount command again, and I can see that it is mounted right there in this new storage directory. I can umount that again, new storage. And then if I want to mount the new storage, I can just tell it to do mount new storage, and it'll mount it because once again, it looks up in the fs tab or file system table file and figures out what it needs to mount and how to mount it. And then I can type the mount command again, and once again, see that it is mounted correctly. Now, if I mess up this file, let's go ahead and mount it first, and then nano etc fs tab, and let's say I tell it some directory that doesn't exist, like new storage without the E. If I try mounting mount dev sdb1, it says mount point new storage does not exist. So if I try mount new storage, it says it can't find it in the fs tab file. So you can see what it's going on here. That's how it's doing it. Now imagine what would happen if you booted up your system like this and you had a mistake in there. Well, that could be bad, especially if it's a critical file system for your system to run. It could cause the entire system to basically crash. You don't want that. That's bad. All right, back to the slides. What features are available with a file system? Well, you have all kinds of features. You have the ability to read and write to files, edit files, set permissions on files. You can use things like SE Linux, disk quotas, all kinds of things. So permissions, how do they work? Well, the way they work in Linux is each file has some kind of an associated number. And the associated number indicates, well, what the permissions are. You have users and you have groups, and you can see all this information with the stat command. So if I go into my file system, new, let's create a new file. So I use the touch command. Actually, it's not mounted, is it? Mount new storage. Go to new storage. Do touch new file txt. If I do a directory listing, I can see that the new file is owned by root and it's 0 bytes in size. It's kind of a small file. If I do stat new file, I get some information about this new file. I can see the size, I can see the blocks it takes up, other information. I can see information about inodes and links, and then I see this access permissions. Well, it says it is 0644. 0 in the front is for things like your set user ID and set group ID and your sticky bit. The 6 and the 44 indicate the user, the group, and the world permissions. You can see the owner is UID 0. The group is UID 0. You can see the SE Linux context is listed right here. Basically, it's kind of unlabeled. And you can see all the information about its access, modification, and change times. So that's all there. And that's all stored, most of that's stored right there in the inode, not the actual file name. It's stored in the inode that the file is linked to. So when you create a directory, your directory has a list of file names, and those file names are pointed to inodes on the system that allow you to then edit and modify the contents on the system. So how does SE Linux work on a file system? Well, you set your SE Linux context, and then the SE Linux piece is tied to the kernel, so that whenever you have access or try to access a file, it looks at the kernel, asks the kernel what it says. The kernel looks at SE Linux and says, yeah, you're allowed, or no, you're not allowed, and it blocks it. It doesn't matter what your permissions say. If SE Linux blocks you, then you don't get to the permission level and you can't see it. So that can be a bit of a problem. It also makes things a lot more secure if you have services that have to run as root and you really don't want them to be able to touch certain files. You can use SE Linux to block them from touching them, even if they have full root access, because they don't really have it with SE Linux. And the file system helps to support that. How do disk quotas work? Well, disk quotas, you have a couple of files on the system, and then those files are updated whenever you make modifications to the file system, and they then keep track of how much space you have, what you're allowed to do, and it protects it. If a file system is read-only, then you read things, but you never modify things, including the access times. Access times for files don't change if you're reading it from a read-only file system. Read-only file systems are great when you don't want someone to mess with something. So anyway, that is your lecture on file systems. People and permissions. On a Linux machine, it's good to know which users are on your system. You need to know who's in there, what they're doing, and sometimes you need to work with the users. You need to remove users. You need to change passwords, delete users, create users, lock accounts. All these things can be done. So let's start with the beginning and look at a system. So here is a system fully logged in, and I can type in the W command to see which users are currently logged in. And I can see that I am logged in as root. Well, okay, that's nice. It looks like I'm showing up twice, 2 different root users. What's really happening is one is this GUI is logged in, and then from within my GUI I have a terminal up and going, and inside that terminal you can see I'm running the W command to see, well, who's logged in. You can also use the last command, last, and it will display all the users that have been logging in, when they logged in, what happened when they logged out. You can get an idea. You can see that down here a few days ago the Joseph user logged in and apparently logged out at a crash. So the system must have crashed for some reason, and that's when the Joseph user was logged out. Ever since then, the only user that's been logged in is the root user. There's also the reboot user, which apparently logged in probably from the GUI when the system was rebooted or shut down. So that gives you an idea of what happened with the system. You can also see, if you jump back to the W command, you can see things like how long the system has been up. And it looks like it's been up for 48 minutes. So gives you an idea of what's going on. All right. So what are they doing? Well, the commands right here is what they're doing. So then how do I create new users, delete users, change passwords? Well, let's start with changing Joseph's password. So I do PASSWD Joseph. I'm logged in as root, so I can change Joseph's password. If it was Joseph, he'd have to type in his password and then type in the new passwords. But I can just set the password for Joseph. So I'll set it to aloha123, then aloha123, and it's set. If it doesn't like the password, let's say I do something like ABC, it says the password is shorter than 8 characters, type in ABC, it will still change the password, but it's not as happy. It just warns you. I can still change it back to whatever I want though. All right, so now the password is set. If I want to create users or delete them, there is this user del or user add commands. So type in user and then tab twice, and you can see there's user add, user del, and user mod are the good commands I can use. So if I do user add and hit it by itself, it'll tell me all of the information about this command. Okay, well, so how do you use it? Well, user add and then the login name. But before that, you can put in a bunch of options. So what options do I want to use? Well, I want to tell it things like, I don't know, the comment. The comment is usually the user's name. I can tell it any groups I want to add it to. The primary group or secondary groups. Just remember, lowercase g is your primary group, capital G is your secondary groups. Anyway, those are some nice things you can do there. User del, same thing. User del, the big difference is that you can decide what you want to do with the directory. So usually I do a -R option to remove the directory when I delete the user. Now, if there are important files in that directory and you don't want them to be deleted, you could remove the user without the -R option, but remember that the user's files are tied to the user ID, and you would have to go in there and change the user ID or change the user ID of the files in order to make sure that the new user, if you create a new user afterwards, doesn't get those same files. All right. Can I lock accounts? Yes, you can. But that requires understanding basically how things work. When you have a user and you have a password, if I look at the etc shadow file, that's where the passwords are stored. You can see that this user, Joseph, has a long password thing right here. It's actually this long section right here is my hash. The first part of it, the $6 indicates which method I'm using. From here, I can see that my salt, this is a random string of characters mixed in, is, well, this. And then this salt gets combined with my actual password using method number 6 to generate this long string right here. And then whenever I type in my password to log in, it will take my password I type in, combine it with the salt, use method number 6, and then see if it generates this exact same long string right here. And that's how you do password calculations. So if I want to prevent someone from logging in, all I have to do is modify this right here so that it doesn't work correctly. So if I do a user mod minus capital L Joseph, it locks the account. So if I cat this, well, let's do a grep Joseph, you can see that something happened. What changed? Well, if you look at it, it's almost exactly the same, except there is now an exclamation point at the very beginning. And that exclamation point makes it so that my account is locked. And I believe I can unlock it with a minus capital U. And then I can see that it has removed that exclamation point and it's no longer locked. So that's how you lock accounts. Groups. Well, what are groups on my system? There is an etc groups directory or etc groups file, and in it, it lists all the groups and it lists who are the supplementary users of those groups. So who is a member of each group? Well, you can see these supplementary members there. Primary users don't always show up. Sometimes they just get it because it's assigned as their group. You can use the ID command to indicate which groups users are part of. And so I can type in ID Joseph to figure out which groups he's part of. And, well, let's go look at that. So ID Joseph. I can see that Joseph is got a GUID of 1000. That means his primary group is, well, the Joseph group. His supplementary groups are Joseph and Wheel. So if I cat out the etc group file, I can see that, yes, Joseph is part of the Joseph group as a supplemental member. And then if I scroll up a bit and find the Wheel group somewhere, you can see that the Wheel group has right there Joseph as a supplemental member of that group. I could go in and add them to other groups by just modifying this file, and that would take effect the next time you logged in. So that can be useful, but you can also use the user mod command to modify him and add him to extra groups. The Wheel group is actually tied to the etc sudoers file. The sudoers file says, well, okay, down here, all people in the Wheel group can run all commands as root. So this Wheel group right here basically means that my user Joseph has the ability to use the sudo command, sudo, and then run something that only root could run. So like ls/root. Of course, I'm logged in as root, so root can do that. But if the Joseph user were to do that, He would be prompted for a password, and after being prompted for the password, he could, well, run that command. If I wanted to change that, I could go ahead and modify this sudoers command and take this one right here, right below it, without a password, and take out the hash mark, and then hash the one right above it. All right, so that's this group thing right here. When you have files, you can see there's a group owner and there is a regular user owner, the owner, and then the group owner. And then the permissions are set appropriately. So this is the user permissions and this is the group permissions. You can set files so that a group has access to the file. And then if a user is not the owner, but they are part of the group, they will still have access to the file with whatever permissions are set. If you don't put them in the group, then they would be stuck with whatever the user, the world permissions are set at. So how do I create and delete groups? Well, group add, group del, just like the user add, user del, except it's much, much quicker. How do I modify group membership? Well, you can modify it using the user mod command or by modifying the group file directly, group file directly. The etc scale directory is really interesting. When you create a new user, the question is, what files do you put in the directory? What files do new users get automatically? Well, they get everything that's in the etc scale directory. All right, so let's go modify that. So if I jump into this directory, so I go etc scale, I can see what they get. They get a bash logout, a bash profile, and a bash rc file, and they also get the Mozilla directory. So I can create a new directory, public HTML, and I see this new directory here, and then any users that are created now will automatically get this public HTML directory. So if I look in the Joseph directory, he does not have the public HTML directory. There's no public HTML because, well, it didn't exist in the scale directory when it's created. If I do user add -c Alice, and her username is going to be Alice. Now, if I look in the home Alice directory, I can see she has the public HTML folder, and she has everything else that was in the scale directory. And not only that, but you can even see the date that these things were added to the scale directory. So if I look in here, you can see April 15th for the public HTML. Once again, April 15th, everything matches. It's just a direct copy of what is in the scale directory. Okay, so that's the scale directory. It's kind of useful. You want to make sure you set it up before you create users. Otherwise, you have to go manually back and create it. So I look in the Joseph directory, and you can see there still isn't a public HTML folder there because it wasn't in the scale directory when his directory was created. How are regular users and root users different? Well, root has access to all kinds of amazing things. They can edit all kinds of files. They can edit anything with that they don't even have permissions for. They can change permissions. They can change ownership of any file. So how do regular users get the right of root? Well, we looked at that just a moment ago. There's that wheel group thing. With the wheel group, sudoers, you are able to run command with run the sudo command and access things that root could access because you can run these commands as root. So what can regular users do if they do not have root rights? Well, they can ask for somebody with root rights to do it for them, or if the root user wants to, it can grant them access so they can do it with the sudo command themselves. What do the RWX permissions mean? Well, R is read, W is write, and X is execute. And that means different things in different contexts. For example, if it's a R and it's a directory, it means you can read the contents of the directory. That means you can see which files are in the directory. If it is an R and it's a file, it means you can read the file. W means you can write to it. You can write to the directory, you can write to the file. X, if it is a file, it means you can run it as a program. It can execute it. X as a directory means you can get into the directory. So that's what executing a directory means, is going into the directory. So can a directory have the execute permissions? Well, we just answered that. Yes, it can. What are sticky bits? Okay. Well, before that, you have these permissions, right? RUX, but you have one more permission. So let's take a look at some permissions in, well, this directory, for example. If I do stat and I look at my desktop, I'm in the wrong directory, aren't I? Let's see back to my root directory, stat desktop. I can see it has these permissions. A 0, 7, 5, 5. Okay, 7 means that it has read, write, and execute. 5 means it has read and execute, read and execute. So that's good. If I create well, let's take a look at the command. If I want to change my password, I use which user bin password. Now, the password command itself edits files that only root has access to. So the question is, how does a regular user run or change their password? Well, they can't. A regular user cannot change their password. The only way they can do it is if root does it for them. So if I do a stat on the user bin psswd command, I can see it has a 4755. The 4 gives it puts this little lowercase s there. And it means that it will run as a root user. So the 4 means it runs as the root. And if you had a 6, that would mean it would run as both the root user and the root group. And then that last bit, the 7, if you went 7 there, is the sticky bit. Sticky bit means that when you run the program, it stays in memory instead of being flushed out regularly. So that could be useful if you're running a program regularly again and again and again. But these are the set UID bits and the sticky bit. So let's go back here. How do programs run as different users? Well, you can use the set UID bits, and that's basically how you do it. If they have the set UID bit, it will run as the user, as the owner of that file. Is a set GUID, it will run with the group set as the group owner of the file. And we talked about the file and directory permissions a little bit. Let's talk a little bit more about file permissions. If you want to run a file, you need to have the execute bit set, right? Well, what if you are running binary files, it just needs execute bit and it runs. If it is a shell script of some sort, the way it actually works is it starts running, it looks at the very first line, and that very first line gets executed, and it passes in the contents of the file to that first line's program, which then runs it. So the very first line of a script is the interpreter. So if you're writing a Python script, it would be a hash mark, exclamation point, and then the directory and path all the way to the Python binary. So hash, exclamation point, slash user, slash bin, slash Python, or something like that. And then what happens is that program is run, and it's passed the URL or the location of this file, and then it tries to read the file. So if it is a script, it needs to have the read bit set, otherwise it will not be able to actually run the program. So binary programs just need the execute bit set, and scripts need to have both the execute and the read bit set. All right, so what are default permissions? Well, so if you are creating new things with root usually creates new files, and it has read, write access to all of its own files. But if a user sets it, it also has read, write, set, but the user sets both the owner and the group permissions, and root sets basically just the owner permissions to be something that's open. And the reason for that is to prevent root from accidentally giving too much rights to things it doesn't want to give rights to. And that is all set with the umask. So let's go ahead and take a look at that. So jump in here and type in umask. You can see my umask for the root user is 0022. What does that mean? Well, if you take whatever it is, so if it's a directory, it normally starts with 777, or you assume 0777, and you subtract that. So a 0777, you're looking at taking 077 off of that, and you end up with a 755. And if you are a regular user, it would be set to a umask of 0002, and that would give you a 775. So imagine your permissions of 0777 minus 0022 for a directory will give you 0755. And for a regular user, your mask is going to be a 0 here, which will give you a 7 here. So that's kind of the idea. So you can change your umask if you want to, someplace along the way in your bash profile or bash RC or something else, and that will get you changed, but you can leave it alone, and that's what happens with the default permissions. chmod and chown. So chmod is to change the mode, or basically change your permissions, and chown changes your ownerships. So how do I change permissions on a file or directory? Well, you type in chmod, the new permissions, and then the name of the file you want to change it to. Chown, you can do chown, the new user, and then the file you want to change. And then you have both a binary and non-binary representations we can look at. So I'm in my directory. Let's go make this new directory temp, and go into the temp. I can see there's no files here. Touch A, B, and C. Now create 3 empty files, A, B, and C. I can type in chmod, and right now their current permissions are read, write, and read and read. So chmod, and I will do group plus write for A. So I added the group write. So if I do ls minus l again, I can see now it has the write for the group. I can do let's see, B, I'm going to do a group plus write, and I'm going to do other minus read. So I'm going to add write to the group, and I'm going to subtract read from other. Now look at it again, and you can see that it has these permissions right here. So if you look at these things, they're all kind of like binary numbers. Well, they don't look like numbers, they look like letters, but if you think about it, the first one has a value of 4, the second one has a value of 2, and the last one has a value of 1. So this first one right here, A, well, it's got 6, 6, and 4. 6 because of 4 plus 2, 4 plus 2, and then 4. If I do a stat on A, I can see that it is, in fact, 664 right there. What if I want to change it to something else? Maybe I want it to be executable. Well, the execute bit is the one, the very last one. So if I do chmod 775 on A, and then I look at it again, 775 makes it read, write, execute, and then read and execute. If I want it to be just executable and no read, no write, then I can do, well, 111. Look at that again, and you can see that it's just execute bits. If I want to make it just writable, then I can make it 222. And you can see that now it's just writable. And if I want to make it just readable, I can do 444. So you can see you can mess with the permissions with chmod and set them that way, both binary and with other things. And you can learn about that more using the man chmod command. You get information about all the different modes and options you have here. And Q for quit. All right, what if I want to change the ownership? Well, I created this new user Alice, so I do own Alice. So I set the user, and maybe I set her to the group Alice A. So now look, and it is now owned by Alice. The Alice is both the owner and the group owner. They're both named Alice. And that's how you change the ownership of files, is with own. All right, SE Linux. What about SE Linux? Well, SE Linux allows you to control files and control access to the files. SE Linux was created by the NSA. So the big question that pops up is, can we trust them? Well, NSA is a group of spies, right? Can you trust spies? Well, they actually did this for their own selfish reasons, because they were required to have mandatory access controls, and Linux didn't really have good mandatory access controls. So SE Linux was built there. SE Linux is the security enhanced Linux. It provides mandatory access controls. So files have these different contexts, and you can change it. And if you mess it up, bad things happen. So let's go look at some files right here. If I do ls minus capital Z, I can see these all have the admin home T context type. You can also see which roles and the user stuff, but we can really ignore that stuff. All we really care about is the type for most of what we're doing. So I can do a chcon for change the context type, and maybe I want to change this from admin home T to conf T, and then change A. Okay, maybe conf T isn't a valid argument. Well, let's see what other types we have. Down the ECC directory, we have, let's do a capital Z. We can see we have etcts. Let's make some of those. So I look at that, and we may change this one to an etct. And now I look at my directory right here, and I can see that it has been changed from an from an admin home T to an etct. If I want to change it back, I can just use the chcon command again, or I can use restore con A, and it will restore it back to what it thinks it should be, which might be correct, it might not be. And you can see it change it back to the admin home T. This is important because some programs are set to only be able to read certain types, and that becomes critical when you start doing things with a lot of servers. But just to be aware that you can do that, you can look at the types and you can change them. And that is it for our peoples and permissions. Software repositories. When you're using Linux, one of the big questions that come up is, what is the difference between Linux and a Linux distribution? Well, Linux technically is the kernel of the Linux distribution. So what we have is we have a system which is a collection of software. And the main piece that runs your operating system is your Linux kernel. So a kernel is the only program that is allowed to access memory, access the hard drive, lots of CPU things. Lots of these things are restricted to just the kernel. So when a computer starts up, what it does is it starts up the kernel. And the kernel is then able to start the other programs that then run. So then you have this thing called kernel space, and you also have this thing called user space. And things that run in the kernel have access to the physical hardware, and things that run outside the kernel have access to asking the kernel for things. Well, the kernel only manages the hardware and other programs and doesn't do a whole lot of user-specific tasks that users see. If you want to run a GUI, that's not run in the kernel. If you want to have a command prompt, that's not in the kernel. All these things are run by external programs that are outside of the kernel. And then you take all these programs that are run outside the kernel and you gather them together to make a working system. The kernel is the main piece, the brain that runs everything, and then all these other things are what makes the user experience. So Linux is the kernel, then a distribution is that big collection of software. People can decide which pieces of software they want and collect them together as a Linux distribution. So you'll see sometimes people say GNU Linux distribution. GNU is a project that includes lots of different commands that you'd use. Your shell, all of your commands to change ownership and change files, and all these things are commands that are written to access or to make requests from the kernel and have the kernel do things, and also provide an interface for users to type things. So the GNU project got combined with the Linux kernel and created this GNU Linux thing. And then you have other pieces of software such as your databases and your GUIs and all these things thrown together and makes a Linux distribution. So can Linux be installed without a Linux distribution? Well, kind of. Yeah, you can install it without a Linux distribution. But basically what you're doing is you're installing the kernel, and then when the kernel runs, it won't be able to do anything. So you really need something. Linux needs to be able to start something that you can use to run the rest of your system. So sometimes you'll have Linux kernel show up in things like Android phones and other devices, but those are still Linux distributions of some sort. So why do we need Linux distributions? It should probably be obvious at this point. You need Linux distributions because you need to be able to do something more than just work with the hardware. You need to be able to work with the users as well, and that requires the Linux distribution. So what do Linux distributions do? Well, Linux distributions come with a set of software, and they assume that this is the software that everyone or most people will need, and they bundle everything that's very common together, everything that makes your system work. At that point, you need to decide which other software packages you want to install. If you want to build your own software packages, they're not part of your Linux distribution. Some distributions come with compilers, some don't. Some you have to build them or add them later. Sometimes they're in a Linux repository. You download them and you get them installed in your system. Sometimes you have to manually go and grab things and build them or install them yourself. So, repositories. What is a repository? Well, the Linux distribution usually comes on a DVD or some bootable media, and then you install it, and it gives you your basic set of files. However, the DVD might not be updated on a regular basis, so that could be a bit of a problem. You might have a bunch of old files that need to be replaced. Additionally, you might have programs and files that you want in your system but are not part of the standard Linux distribution because they're not very common, or they just assume that most people won't need these. They've taken what most people want and put there, but a DVD is limited really only to about 4, and I have gigabytes of data. So all the other things you might need but aren't on that DVD are stored in repositories. So a repository is basically like a website with a base file that indicates what files are there, and then it has references to everything else. Inside these files, you also have information about what packages need. You need to know which dependencies each package has, and this is all stored kind of in the repository so you can download and build packages. So what's the difference between a repository and Linux distribution? Well, the repository is your extra stuff. It also includes your Linux distribution as well, but it's everything else you need. It could be terabytes of data, terabytes of files and programs, different versions, different things you might need to install in your system. A Linux distribution is more of this smaller, confined grouping for getting you started. So what repositories, or which repositories, does my system have? And how do I add additional repositories? And why would I want to add more repositories? And then are there disadvantages? So let's go ahead and take a look at a Linux system. So right here we have a Linux system. So if I go down to the etc directory and I go into the yum.repos.d directory, I can see a list of files. And all these files have the repo extension. These are my standard repos. So I can go in here and I can look at each of these files. So the CentOS base, let's take a look at that. Let's CentOS base. And I can see that it has a bunch of comments, and then it has this base thing. And it looks like a name, and then it has this mirror list, base URLs, GPU check, things like that. So what do we have here? Well, the name is the name of the repo. The mirror list is where you're going to find your files to download. You have this base URL as well, which gets you started there. The GPG check basically says, well, these packages could be signed. Do we want to check the key to make sure they're signed by the person who's supposed to sign them? There's this whole public key, private key thing. And once the repo is installed, you need to accept the key, and then any packages that are created and added to that repo get signed with their private key, which you can then verify with this public key. And the public key is right below in GPG key. So this base contains a whole lot of files. And then after that, you also have updates, extras, different repos that you can look at. There's also one thing you want to look at, the very bottom one, CentOS Plus. There is enabled equals 0, which means this one is not part of your lookups. So how does this work? Well, when you want to install something, it has to go look in the repos, you have to download files. Let's add an additional repo. So one that's very common is the EPEL release, or EPEL repo. So I do a yum install EPEL release. This is a package that will give me the repo files for the EPEL repo. And you can see right here at the very beginning, it did loading mirror speeds. You can see it's looking at your base, your extras, your updates. These are repos that are active, and it's going through and grabbing these and checking these, making sure that you have everything you need. It looks at the dependencies in order to get the EPEL release, figures out if there's any dependencies that need to be installed, and there aren't any, and then asks me, do I want to download and install it? And I say yes. I could do D for download and just download it and not install it, but Y for downloading and installing. And then it installs this EPEL release. So then if I wanted to do a yum install EPEL release again, it's already installed, but you'll see, looks like my GUI decided to take over.
I can kill that process. Sometimes the applet on the desktop decides to take over. Alright, so I yum install EPEL release. And now you see, in addition to checking base, extras, and updates, it also checks EPEL to see if there are packages here. Now if I take a look at my directory again, I can see that there is a new set of files right here. There is the EPEL repo file. So if I take a look at that one, I can see it has a list of things as well. I can go through and I can disable the EPEL if I want, or I can leave it enabled. You can see there's two other ones right here that are both listed as currently disabled. If I wanted to get the debug info versions, I could just turn on this one right here and probably turn off the other one. If I want to get source code, I could get the EPEL source and just enable that one. If I wanted to install a package from the EPEL release, Alpine, which is a great mail client based on the Pine client, is part of that. So you do yum install Alpine, and then it looks and it says, okay, you want to install Alpine, and it says Alpine right here. It says Alpine is part of the EPEL repository. It also requires mailcap, which is part of the base repository. So you can tell where you're getting it from. So I do Y. It downloads this mailcap, and then it says, wait a second, we don't have the key installed for EPEL. So I look at it and say, do I want to install it? Yes, I want to install the key. And I install the key, and then it installs both of the packages. So that's how you get the new repo. That's how you use it and get it in place. All right. Where are the repository files stored? Well, that's in the etc directory, etc yum.repos.d directory. So you can see those. Can they be edited from the command line? Yes, they can. You can go in there and change them. You can disable and re-enable them. You can also remove these on the command line. So you can delete the repo files. Once you delete a repo file, it will remove the repo from use, and you will not have to worry about it taking up memory every time you do a yum update. Also, it doesn't then give you the option of downloading the packages from that repo, so they are removed. How do I update packages on my system? Well, we have a system, and I probably have updates. So how would I update packages? Well, let's go take a look. If I go back over here, let's clear the screen, and if I do a yum update, it will then check all my repos, and it will see I have lots of packages that need to be updated. So I can say, okay, let's update them all. So I do a wide update them, and then they start updating. The first thing they do is they start downloading, and after they've downloaded all the packages, then they will start installing the packages. Now, if you have not accepted your key before, it will then require you to accept your GPG key before it will install the packages. How do I search for new packages or for new programs provided by the repository? Well, you can use the yum command once again. You do a yum install to install things. You do a yum update to update. If you want to search, it is a yum search. So if I wanted to find something such as Alpine, which I've already installed, I could do a yum search Alpine. Now that could be quick, could be slow, but much faster than just going to the web maybe. Sometimes the search will not tell you which package to install because you use the wrong search terms, so keep that in mind. It doesn't find everything always. How do I install new programs from a repository? Well, you use the yum install and the name of the package you want to install. And then how do I know which packages are installed? Well, there are a couple of different ways you can look at that. When you use yum, yum keeps track of all the packages that are installed in your system. However, there is the possibility to go around that because yum is actually a front end for the RPM package. So RPM is what's used to actually install and remove packages, and yum is a front end that downloads repository dependencies and everything and installs everything and keeps track, but you can look at things with RPM by itself. So let's jump back over here and we have everything installed. If I do a RPM minus QA, I will query all packages, and this will list all the packages that are installed on my system. You can see that there are things like, well, it's a name, the name of the package, you have a version number, you have a release basically for which repo, or not repo, which distribution it is, and then which architecture this is specific to. Most of these you can see is x86-64, which means it's the 64-bit version for the x86. So it runs on the newer processors. No arch means that it's really configuration files or something that doesn't depend on a specific architecture. If I wanted to do a update of something, I just update everything, but I could do a yum update and list a specific package like nmap. It will check to see if there's any new updates, and there are, well, none. If you want to install a package that isn't installed, let's see if we can find something that's not installed. So maybe bind yum install bind utils. Well, it's already installed. So you can install packages that way. If I want to search for something, I can do that. Let's say I really want to run a web server. So I can do a yum search web and see what shows up. It shows everything that has web in either the name of the package or in the name of the, or in the description. So you can see lots of things here. It's usually best to figure out what package you want to install, and that helps you narrow it down. So if you did a yum search for web server, you might find a shorter list which might include what you want. Now typically people use Apache, and Apache is not listed in this list of packages. So how would you look for it? Well, you wouldn't search for web server because that didn't work. You might have searched for Apache. And then you come up with this list that includes other things. You got like Apache Commons and all kinds of things. And you start saying, well, which one is it? Which one has Apache? Well, it turns out it's the HTTPD package. And you can see httpd.x86_64 is the name of the package. It's actually, the package is called HTTPD. It's the architecture, and this is the description. So if I want to install the Apache web server, I do a yum install HTTPD. And then you can get it installed. So now we know how to install packages, how to update packages, and we also know how to figure out which packages are installed on the system. And this is your brief overview on using software repositories. Programs and scripts. So what is the difference between binary programs and text-based scripts? Well, binary programs are basically programs that are files made out of machine code readable stuff. And then text-based scripts are human readable programs. So when you run a binary program, well, there's multiple parts to a binary program, but one of the main parts is you have actual machine code that is understood by the CPU, directly. In a text-based script, what you have is human-readable code that is interpreted and converted to instructions as it runs. So the binary programs are going to be much faster, and the text-based stuff is going to be much easier to read, modify, and update. So how does the operating system tell the difference? Well, there are pieces in the very beginning of a program that indicate what it is. So for a script, they all start with the hash and then exclamation point. And after that, they have the name of a binary program that's going to be run. And then what happens is it reads that, it sees the name of the binary program to run, it runs that program, and then passes the script as input to that program. So that causes the interpreter to then interpret that script and run it. So how do users tell the difference? Well, it's pretty easy. You just open the file and take a look at it, and if you can read it, it's probably a script. If you can't read it, it's probably not a script. How are they made? Well, you use text editors to create your text-based scripts, and use compilers to take source code that's made with a text editor and convert that to binary. So the conversion process happens with a compiler. So what is a compiler? Well, a compiler reads through a source code file, and it will then interpret and figure out what this means and convert it into binary data that can be understood by the CPU. It's the same kind of thing as an interpreter, but it converts it all the way down into binary and stores it as binary. They still have to do the same kind of thing as interpreters because they both have to read what the human readable version is and understand it. So why would I want a compiler? Well, you need a compiler every time you want to write binary or create binary files. And that could be because you need to download some source code someone's provided. You need a compiler to do that. And you also need it if you're going to create programs that are not going to be script-based programs. So which compiler should I get? Well, that depends on what the source code is written for. There are multiple different compilers out there, but the most common one on Linux systems is the GCC compiler. So it's the GNU compiler. And that one is the one that I would recommend, especially if you don't know any other one that you need. Although it is possible there are some minor differences in the source code, and different compilers will be required to do different things. So you need to make sure if you download some source code from somewhere, you figure out if it requires a specific compiler or if it'll work just fine with the GCC compiler. So building source code. Where can I go to get programs that are distributed as source? Well, a lot of people go to GitHub. You can go to GitHub and you can download source code there. You can also go to other source code places such as SourceForge and download your source code there and get it. Many different people who are creating projects have a source code distribution that you can download as well. But then you have to figure out how to build the source code programs. So how do you do that? Well, that can be tricky because sometimes you have all kinds of libraries that need to be compiled and built into it. So you need to make sure you have all the libraries, all the dependencies, everything. You need to make sure you have the compiler, one that'll work. Then you need to sometimes run scripts on it to then prep it up. Sometimes there are configure scripts that will check your system and see what hardware, what packages you have, and then customize your build to use that. Then they have makefiles. Makefiles, you run the make command, and that will install all of the, well, it'll build everything according to the makefile instructions. So that seems kind of complicated and difficult. So why would I want to build my own programs or build them myself? Well, you want to build them yourself because it gets more efficiency, or because they are not built, or maybe you want to make changes and you can't make changes to someone else's binary very easily. So you need to build them yourself. So how then are source code projects installed? Well, what happens is if you use a package management system such as an RPM package, it installs and it puts files all across the system in different places, but it keeps track of where they're at. If you do a source code project, you can do the same thing. You can put them all across the system, wherever you need to put them, and then you need to keep track of where they're at, or you need to make sure there's some way, some script in there to remove them, because otherwise removing them can be very difficult. So, what does a hello world program in C look like? And how to use the GCC compiler to convert source code to binary. And then we'll look at the make file and then how to run the binary program. So let's jump right in here. So let's make a file. So I'm going to make a directory first. Make dir, and I'm going to make this the hello directory. And I go into hello, and now I'm going to create a file. So I do nano hello.c. So your C files end up with the C extension, and in it you have to tell it you are using your libraries stdio standard input output .h, and then in main you have to have main function. You can pass the variables here, or you can just skip that and go directly into your main function. And in the main function I can do a printf to print hello world. I have a new line, so it's not on the same line. And then I want to make sure I have a return value so that when the program ends, it knows that it returned successfully. Return 0. So that's really about it. You can do much more complex. You can add things like int arg c, char, maybe star char arg v. You can do whatever you want here, but you pass in variables. Anyway, so let's go ahead and save that and exit out. Next, I want to compile it. So I need to use the GCC compiler. If I try and running it right now, I don't think I have it installed. And it says command not found. So I need to get my compiler. So I could search for the GNU compiler and find it that way, or I can just do yum install GCC. And that will get it right here, get it all installed. And that's kind of quick. The compiler does take a little bit of time. It's a little bit bigger than the average package, but it's not too hard to install. I get it installed, and now I can try compiling again. So I do a yum install, actually not yum install, do a gcc hello.c. Now I take a look at my directory, and I can see I have two files now. There's the a.out and the hello.c. So if I do /a.out, it runs hello world. If I don't want it to be called a.out, I can change what it's saved as, or what it's created as, in the command gcc hello.c -o for output hello. So I want it to be called hello. So I do that. It creates, instead of the a.out, it creates a hello dot, or just a hello binary. You can see it's the same size as the a.out. If I run hello, it runs. And the way to run it is, because the current directory is not my path, I have to tell it a relative location, which is the period directory's current directory /hello. So then what's this whole thing about make files? Well, if I do a nano make file, I can go down here and I have my hello. In order to create hello, I need to make a hello.c file. And every time hello.c changes, I want to run this command right here, which is gcc hello.c -o hello. I can also have another option here, so a clean maybe. And I'm going to remove hello. So it removes the hello binary. Exit out of that. So I'm going to do a make, and it says hello's up to date. I do make clean, and it removes the hello. So do a ls -l. I can see that hello dot C is there, but hello is not there. So then I do a make again, and it compiles my hello program. So that's how I convert my source code into a binary file using GCC and also using a make file. Gives you a bit of an idea how it all works. All right, how to run the binary program? Well, you want to make sure you tell it which directory it's in, and then you run it. So period slash the name of the binary program. So what does a hello world program look like in Perl, Python, or Bash? Let's go back in here and take a look at each one of these. So Perl, it uses the Perl executable. So if I do which Perl, I can see it's in user bin Perl. Now, a source code file, Perl usually has a PL extension. So I do nano hello.pl. I want to tell it right here to use user bin Perl, use that binary, and then when I run it, I want to do a print, and I want to do hello world, and the new line, and a semicolon afterwards to print hello world. This right here basically it runs with this stuff in the beginning. It says, okay, this is a script. I'm going to run this program, and I'm going to pass it this entire thing as the input. So exit out, save that. Now I can see that the permissions are not set to executable on this PL thing, so I need to set them to executable. So do chmod 755 hello.pl, and then I do period slash hello.pl and oops, .pl, and that runs. Now let's try it with Python. Nano hello.py. This one's a little shorter. Well, not shorter. User bin Python print hello world. You don't need the new line character, and you don't need the exclamation and the semicolon at the end either. This will just work like this. Chmod 755 hello.py. Run that hello.py, and that runs. Now, bash or shell scripts use the echo command. So I do nano hello.sh, and I don't need to tell it an interpreter. I could, I don't need to, because it'll just assume if it's a text file, it's going to be run as a, well, as a script. So I do echo hello world, and that's it. So I run that. Oops. Sh. hello.sh, and that runs. So those are your shell scripts. You can see how they look. The shell script could be done as a, I could actually pass it the bash if I wanted to. So do which bash, which is user bin bash, and then do nano on my hello sh, and I can put that line at the top. User bin bash, and it will run the same. And there we go. All right, so multiple different ways to write a program and make it work. Standard in, standard out, and standard error. So how do I use a text file for the input to a program? Well, many programs can receive input and you type in input. What you can do is redirect these things. So standard in is whatever you type in from the keyboard usually. Standard out is what you print to the screen. And standard error is what you print to the screen if you can't see things, if you wanted to put out error messages. So how do I redirect from standard in, or from a file to standard in, or out from standard out into some other file? Let's go ahead and take a look at some of those things right now. If I do a command like cat, it's now taking input from my command prompt. So I can type things in here, and then Control Z to end. Well, that doesn't end. Control C maybe to quit. Or I can do Control D to end. That's what it is. What I can do is do cat, then redirect from output, or redirect the output into this new file.txt, and then I can type in things right here like hello new file. Press Control D to end that. Now if I take a look around here, I can see there's a new file.txt. I cat out this new file and see it has contents. I could do something like ls-al, and that lists the directory. Then I can redirect that into new file, and it will replace the contents. So then if I cat out the new file, it will list what was in the new file. I can also redirect standard in, or redirect it so standard in comes from something else. So the cat command, we just saw cat. I can, instead of typing something in, I can say, well, I want to give my hello.c file as the input to cat. And then I want to redirect the output into my new hello.c. So what does that do? Well, it takes the cat command, it sends all the hello.c contents into that cat command, which just prints it out, and then it redirects the output into new hello.c. So if I cat out new hello.c, I would expect to see exactly the hello.c contents. They're the same. So you can redirect the standard in or redirect that. Then there's standard error. So if I do some commands, such as, I don't know, find, if I do ls-al dev, it does searching there. I could do a grep to search for something, grep. So I look for the word hello in the etc directory, all files. Some of these things are directories and it cannot search them. Well, I don't want to see this directory stuff, so I can decide I'm going to do this, but I don't want to see the errors, so I redirect the 2 into dev null, which basically throws it away, and then I see everything that doesn't have an error in it. So there you go. If I wanted to get rid of all the stuff that does look normal and only have the errors, I can get rid of my regular output and just see the errors instead. So that's redirecting file input and output. So let's clear that. Using pipes. Which character is the pipe? If you look on your keyboard, above the enter key, there is this, well, there's a slash usually. It's not always on the same place on every computer, but there is this vertical line. So let's use the pipe command. So if I run hello, /hello, it prints that. That's nice. If I run a different command, like WC, well, WC does word count. So I can take this and redirect the input into the output, or the output into the input of WC, and it says, okay, we have one line with 2 words and 13 characters. Okay. So now I want to try doing something more exciting. Let's do ls minus al. That's quite a bit more. I'm going to redirect that into wc. It says, well, 12 lines, 101 words, and 566 characters. And that's nice. But what if I want to do something like sort this? I can sort it. Sort. Well, now these contents have been sorted alphabetically. Not quite the same thing, but I do that, and then I can run through word count. Same thing, obviously, but you know, it does sort it first and then runs it through. So you can run multiple different things and run multiple programs at once. Just have it pass the output into the input of the next thing until you're done. So that's pipes. File types. What types of files exist on Linux machines? Well, we have these different letters when I do ls minus l. D is for directory, L is for link, B is for block device, and C is for character device. So you can look around and see things. Do file extensions mean anything? Well, they're used by some programs, but they don't necessarily mean anything critical. What does the file command tell me? Well, it tells me something interesting. It tells me what the file is. So let's jump back in here and take a look. So if I do file star, it tells all these files what's in them. So a.out is an ELF binary. Hello is an ELF binary. C is a C source code, ASCII text. You can see each one of these things, it lists what they are. So ELF is the the Linux file format for binary files, because it has not just binary code. It also has things like memory and other things all set up in there. And so it uses that. So you got to make sure you know how these things are. If it says ELF, it's a binary. If it says text, it's not binary. It's text, right? So you can keep track of those things, and that can be useful for figuring out what type of file you're working with. So the last thing right here is symbolic links and hard links. So let's take a look at them. So we have over here, we can do a symbolic link. So if I do ls minus, or ln for link minus s, I can do hello, because that's my program, and I want to make it a symbolic link, hello 2, and I can do a hard link without the s, and do hello 3. So then I take a look at my directory. There it is again. So the ln does a link. The 2 created a symbolic link. What that does is it says hello 2 points to hello. So if I deleted hello, it would be gone. Hello 3 points to the same address of memory as hello. And you'll notice over here, there's this number 2. That's the number of links pointing to that actual content on the disk. 1, because it's just a link. It's telling where to go. The 2's right here are both addressing the exact same space in memory. So then if you edit them, if you edit any one of those 3, it will edit the same exact file. However, some editors, when they make file changes, will save a new file and then move the new file to replace the old file. So keep that in mind. When you want to unlink them or delete them, you can do either delete or remove, or you can do unlink. So unlink hello, and I look at my directory listing, and I can see that now the hello 2 says, oh, there's no hello. But hello 3 is still fine because it points to the memory, and the number 2 has decremented down to 1. So the hello 2 doesn't work, but the hello 3 still does because it pointed to the actual program. And then you can go and remove or unlink things like hello 2. All right, so that's your symbolic links. And I think this helps you get an idea of how programs and scripts work on Linux systems. And that's it. Services and firewalls. On a Linux machine, one of the questions you might ask is, what is a service? And then a related question might be, what is a daemon? So a service is basically some program or something that runs in the background. Something that serves requests and answers things and helps you work. So a web server is a background program that runs, and when requests come in from the outside, it receives these requests, processes them, and then sends out pages and information. So that's a service. There's also other services, such as a time service, which will sit there and periodically go and check to see what the time is, compare the time to its clock, and update the clock depending on the differences. So that would also be a service. So then what's a daemon? Well, a daemon is basically, or a daemon, is something that operates in the background. So basically the same thing as a service. So where did the name daemon or daemon come from? Well, there's this Maxwell's daemon thing where it just serves its master. So which services do I want running? Well, that can be a tricky question. It depends on what you're doing with your server or with your machine, what you're running, what you need to run, and how your machine needs to react. But there are some services that are kind of essential, not really essential, but kind of essential, such as the mail server. So all Linux machines, all CentOS 7 machines, have a mail server running. And the reason for that is not so they can receive mail, it's so that the other services have a way to communicate back to the administrator that something happened. So things like your cron jobs, your tasks, will send a message to the administrator when something produces output that's being run as a job, so the administrator knows something happened. So that's going to be useful. There are other services that keep track of things like if you're doing DHCP-based addressing, your DHCP service needs to run in order to maintain and update your lease so you don't run out of IP addresses. So then the question is, which services pose security risks? Well, any services that can be accessed from the outside or the inside pose a slight security risk. The more rights a service has, the more of a security risk that service becomes. Managing services. How do I know if a service is running? Well, on newer systems with a systemd as the service or the system running the machine, you can use the systemctl command for system control to check to see if a service is running. You can also use other programs to check to see which processes are on the machine and try to figure out if a service is running that way. It's probably easiest to use the built-in service checking utilities. So let's take a look at the systemctl command. So we have on a default machine a couple of services running. You can type in systemctl status, and that lists a whole bunch of stuff, which is kind of useful, but then you're like, well, what does all this mean? Many of these services you can see are running. You can see process numbers, what was used to start the services, and that can be useful. But let's say I want to look at a specific service. I want to know if the SSHD service is running. So I do systemctl status SSHD. Right here I can see that the service is running. The green active indicates that it is running. So you got to make sure you can keep that straight. The active green right here says it's running. Then you might see this other thing, enabled. What does enabled mean? Well, enabled means that it is not just running, but it will start at boot time. You also see this vendor preset enabled also. So when you install the software, it assumes it needs to run, and then it's currently set to enabled. If I wanted to not start at boot time, I can disable it. And if I want to stop the service, I can stop the service as well. So let's do a check right here. So if I do system ctl disable sshd, and now I look again at the status, I can see that it is still active and running, but now it says it is disabled. So it will not start on boot time. If I do a stop on SSHD, the service stops. So if I do a system check again, I can now see it is inactive or dead, and it is still disabled. If I want to enable it, enable, and I look at it, you can see that it is enabled, but it is still inactive and dead. If I want to start it back up again, I just do a start. Now, one thing you might have noticed is when I disabled and re-enabled, what it was doing is doing something with symbolic links. You can see it created a symbolic link. So etc system system D system multi-user target wants SSHD service. So currently my run level is multi-user target multi-user. So in this directory, there is a list of symbolic links that include the sshd.service symbolic link, and they link over to another place on the system, user lib systemd system sshd.service, which is where the service scripts are actually located. So we'll be looking at that a little bit. So will the services be running after I reboot the machine? All you need to do is figure out if they are enabled. And you can change that using the systemctl enable or disable commands. And you can start and stop them with the systemctl start, stop, and you can use restart as well. So how does the system use the scripts? Where are the scripts stored? What is contained in the scripts, and what does it mean? Well, so when you go over and you look at these scripts, so let's take a look over at them. First, we'll go over to the etc directory, system D, system, and then multi-user target wants. I can see there are a lot of symbolic links, and these links link over to my actual scripts. And these are the services that start. In older startup processes, so we have a system D right now, but before that we had init. And init had this thing where each service had a number, and that number indicated the order in which it was started. And so that was great. You just need to make sure you know which number your service needed, and it would start before things that required it, and it would start after things that it required. So you just figure out what number they had, and you put it in the right place. This is different. With systemd, now it can look at the dependencies in there. So if you think about the SSHD service, what does it need? Well, it's a secure shell that you use to log in over the network. So what does it need? It needs to have networking working, right? So we cat out the sshd.service. It shows us this is our OpenSSH server daemon. It's got some documentation information. It has to be started after network.target and the SSHD keygen service. So it needs to actually have a key in place. It wants the SSHD keygen service, And then it's got all these other pieces of information, tells you things like how to start it, how to stop it. And that's all used by the system CTL command when it starts and stops things to make sure that things are ready. Also, when you're doing, when you're enabling it and you're booting it from the beginning, it will take a look at these things and figure out which services need to be started in which order, and calculate out that little tree, and then start things in the order to make them work. All right. NetStat. How do I know if my services are really running? Well, we've started the SSHD service, and systemctl tells me that SSHD is running. But is it really running? We know that the SSH service listens on port 22. So we want to figure out if it's listening on port 22. So let's go and take a look. So if I type in netstat, it lists all this stuff. And you can use different letters. So I want to make sure I use my TCP and UDP, and I want numbers instead of names, and all of them, so I do tuna. Netstat minus tuna. And then I can see this right here. My SSH service is running on this right here, which is useful information, because I can tell, oh, SSH is listening on all IPv4 interfaces, and it is port 22, and it's in listening state. I can also look at this thing right here, and it says it's also listening on IPv6 interfaces, so all of those, and it's in a listening state. If I want to see a little bit more information, I can add the P option, which will show me which processes are running these things. So I can see that the SSH service right here is using the SSHD process. And you can see the same exact process ID number and program name is running on the IPv4 version right there. So IPv6 and IPv4 are both running. They're both TCP. I don't see anything with UDP, but I can see other processes here that are running and what's going on. So how do I know if there are any current connections? Well, there aren't any current connections right now, but if there were, you would see something about established connections, not just the listening. Because this right now is just listening, but no one's trying to connect to the SSH service. Nmap. Are my services visible from localhost? Well, that's an interesting question. So let's go back and take a look. So if I do a yum install nmap, and I recommend nmap to anybody who wants to be a decent administrator. It was considered originally kind of a hacking tool because you can scan ports and things like that, but well, it's useful for other things too. So nmap localhost, and then it comes back and says, oh, when I did a scan on localhost, these are the ports that responded. So one thing you want to pay attention to is it says not shown, and it says closed ports. So what are closed ports? Closed ports are ports that when I tried talking to the ports, the kernel responded and said these ports are not open. And that means they got past the firewall. Then I got this thing right here where it says these ones right here are open. Okay, so SSH is open. SMTP is my mail service, and it's open for at least a local host, so local connections. RPC bind is for some things like network file system and NIS, some of these things. And then there's the printing thing right here. So IPP for your internet printing, that is actually run by the CUPS service. Now, if I say, well, what's my IP address? If I do IP adder, you can see my IP address. It's kind of hidden in here, and it is the 10.0.2.15. So I want to scan that one. So the nmap 10.0.2.15. Since I'm on my own machine, you'd expect to see the same things, right? Well, not quite. Some of these things are only listening on localhost. So the mail service, procmail, was only listening on localhost, and the print service was only listening on localhost, but RPC bind and SSH are both listening on the external interface as well. So what would I see from the outside? I would see anything that gets through the firewall. So SSH is currently getting through the firewall. That's the default configuration, but RPC bind would not get through the firewall. So externally, all I would see is the stuff getting through the firewall. So let's go ahead now and take a look at what a different machine would see. So switch over to machine, and right here, I can use nmap to scan 10.0.2.15 and figure out what gets through. So what we'd expect to see is the SSH service getting through, and that's all we see. Notice how it doesn't say closed ports right now. It says not shown 99 filtered ports. That's interesting. So what does that mean? It means that the rest of them didn't actually send a response back. So that means there's a firewall. Scheduling tasks. How do I schedule tasks? Well, you can use the cron tab service. And there are different places you can look at for scheduling tasks. The most common is using the cron tab -e option. So let's take a look at that. So clear this out. Let's go down to var spool cron tab cron. So if I go to var spool cron, I can see in this there is nothing here. If I do cron tab -e, it will use your default editor, and you can go in and put something in here. So you can put in a bunch of different numbers. So if I want something to run every minute, I could do this right here, and then I can type in some command. Now, one thing to keep track of is that cron, when it runs, it does not necessarily run with the exact same environment that your user logs in and runs as. That means that file locations and executable locations might not match exactly. So you usually want to pass in the not just relative, but the absolute path names for everything. So what do I want to do? Let's find a Control-Z switch. No, can't do that. Let's go ahead and leave a comment here. And let's figure out what command we want to run. So we write and quit. And if I type in a command right now, like ls, it tells me what's in my directory. And if I do which, actually that's the part of bash, which ls will say it's really an alias. But let's try this user bin ls. So if I type in user bin ls and go back to my cron tab -e for edit, and then I for insert mode, type user bin ls, then I can write this and it will install a new cron tab. And if I take a look at my current directory, there's this thing called root. If I cat it out, you can see it is that text file I just edited. And now, I put it here in my var spool cron directory. Didn't have to put it here, but it does because that's where it puts all the cron tab files. It's not just because I'm in this directory, it's because that's where it puts them. So now it's supposed to be running every minute. So you can see that in about 30 seconds it'll run again. So then what were all those stars? I put 5 stars there. So I look at my cron tab, information, you can see all this stuff here. It says, here you go. There's a bunch of stuff about using cron tab to get in here. If we want to see more information and actually see what these things are, we look at not the cron tab file, not the cron tab executable, but the information page. So I can do man 5 cron tab, and now it'll tell me the information about how to set up cron. So I scroll down and it says, okay, there are 5 fields. The first one is your minute field, which if I put a star there, it means every minute. If I put a number there, it would mean that minute. So if I wanted to run on the hour, every hour, I put a 0 there. And then if I wanted to run maybe every day at midnight, I could put 0, 0, and then 3 stars. Then I can limit things like the day of the month. I can pick which day of the month from 1 to 31. Some of these days of the month might not be hit. 31 might not show up for every month. So maybe you run things on the first day of the month, or maybe some random day in the middle of the month. You can pick which month, 1 to 12. You can also pick the day of the week, which is 0 to 7. So 0 and 7 are both Sundays. There's also other combinations. You can do commas to separate multiple different things, and you can do slash things. I usually do things like */3 for every 3 minutes or hours. And that can be useful. All right. So now if I look at my date right now, I can see that some time has passed. So the ls command should have run multiple times. So if I go over to my mail, bar spool mail, I can see there is a root file. And if I cat out my root file right there, I can see all the mail. And it's probably generating something, but maybe not. Sometimes when you have a cron job that runs, it produces mail. So just be aware of that. All right, so that's how you schedule tasks as a normal user or as the root user. There's also the etc cron directories. So there's etc cron.d for your configurations, cron.daily, cron.hourly, monthly, weekly. So if I want something to run every day, I can do cron daily. And in this cron daily, I can see that these 3 commands are running every day. It doesn't tell me when they're going to run, but they're running every day. And now it says I have mail in my root directory, or root mail spool. So if I cat out this root thing, it looks like it is running again. And you can actually see this is actually output from the ls command. It's running in the root directory, and these are files in the root directory. Doesn't matter where I'm at right now. If I look at the root directory, I will see the same files, but it's running it slightly different. It's not running it the same exact way, but you can see how it's slightly different when it runs versus when I run it by hand. All right, so that's scheduled tasks. How do you know if a cron job runs? Well, you don't necessarily know if it runs if it produces no output, but if it does produce output, then you can see it right there in the mail. So firewalls. What firewall is used in my system? Well, it depends on which system you have, but it's changed quite a bit. When I first started using Linux, the Red Hat distribution I was using had IP chains, which was later replaced by IP tables, and now we are in CentOS 7, which is a little bit different. It uses IP tables kind of in the background, but it really has Firewall D as a front end to it. So it uses kind of both things there. Firewall D is kind of a front end to manage it. But in CentOS 8, they are switching out firewall D and go into something different. So just keep that in mind. They keep changing back in firewall. So firewall D is what's used on my system, but you can use IP tables as well. How do I see the current firewall configuration? Well, you can use the firewall CMD command to look at it. So we can look at that, how to open ports and services, and figure out which services are supported and how I do a permanent service and what that means. Okay, so let's go back to my home directory. If I do firewall wall dash CMD, no space there, dash dash list all, like that, it will list which services are allowed through the firewall. This is the active current services getting through. You'll also notice this is the public firewall rule, and we can see the SSH services getting through, and we know that was getting through because we already did an nmap. And we can see this DHCP v6 client service is allowed through, which means that if I'm running as a DHCP client, then I'm allowing responses from the DHCP server to come back into me and tell me what my IP address is. So that's important. Nice things to know. What if I want to add a service? So I do firewall CMD add service equals HTTP. So add the web service. It says it's successful, and I think, well, okay, that's great. But if I reboot my system, it will no longer be in my firewall because this is an active only change. If I wanted to be permanent, I would use a dash dash permanent. But let's take a look at what this does. Since I'm not running a web server, what if I jump over to a different machine and scan myself again? So I jump over here and I scan myself again, and I can see that the SSH service should still be open, but now it should say something different about HTTP. It says HTTP is closed, which means that the firewall is open, but the service is not running. So keep that in mind. That's what that means. I should probably stop my cron job. So I do cron tab -E, and I can just do D equal times and quit. There we go. All right. So where are these rules stored? And how does that all work? Well, if I added the HTTP firewall service. If I wanted to get something else, what do I have? Well, I can do a firewall all CMD get services, and that will list a complete list of all of the known services. So that's quite a few of them. So how do I make it all work? Well, I have to figure out which service I want, and then I have to turn on that service. What do these services do? Well, we can probably assume that when I turn on the HTTP service, it turns on the port for HTTP, which is port 80. And we probably saw that when we were looking at nmap, we just didn't pay attention to it. So, now what do we do? Well, we can now take a look at some more information here and see where does this actually get stored. So I take a look and we look at the user lib firewall D, and you can see there's a bunch of stuff here. And one of these things is the services directory. So if I look in there, I can see the exact same list of services. But what does SSH do? So I can cat out one of these services, cat SSH, and I can see it says that I'm going to allow HTTP, for when I'm going to start up SSH, it will do TCP port 22. If I wanted to look at something different like DNS, what does it do? Well, it does two different things. It does TCP port 53 and UDP port 53. So most queries when you're doing DNS lookups are UDP, but if you're doing a zone transfer, it does TCP. So you could modify this or change it if you wanted to. I wouldn't recommend it. Or you can also add new services here. Just put in the information right here. So we can see what services are there. Now, what else do we have? If we look at the etc directory, there is a firewall D thing, and in here there is zones and public. So there's a zones public file. If I look at this thing right here, I can see some information. It says that SSH and DHCP version 6 client are both listed in this file. What happens if I add something permanently? So I added the HTTP service. Now I do permanent. And I look at that same file again, and you can see that it has been added to the file at the bottom. This does not make it active. It means the next time the firewall service will start up, it will add that to the firewall. If I remove it from this permanent thing, so we do del service. Nope, not del. It's remove. Remove service. It removes it from the permanent, but it is still in the active. So we do firewall cmd list all. I can see what is currently active. And if I want to see what is in the configuration file, I can look at the file, or I can add the -- permanent to it and see what is in the configuration file. So you can see actively we have all three of these. In the permanent, we only have these two. So that's interesting to pay attention to and be aware of. So where are the firewall files stored? Well, we just saw that. Can the firewall be updated using the files? Yes, you can update it using the files. You might need to restart the service, but that's you. And can you add additional services? Yes, you can. So you can go in there and just create new services, just use the same file format and create them too. And that is services. Let's look at ports and then we'll be done. So I'll add over here. Let's say I want to add port 123. What is it? I don't know, but we'll add it anyway. So we did firewall. We did add service equals something to add a service. And if you want to do a specific port, you can do add port. Then you got to figure out what's the format. Well, you got to remember if it's TCP/123 or if it's 123/TCP. And one of them will probably work. So you can try both and figure out which one works. In this case, I did the 123/TCP and I added it. It's not permanent, so if I restart my firewall, it will be gone. So let's take a look at that. So if I list all, I can see there is a ports section and ports are listed. If I restart my firewall, actually let's do systemctl restart firewall D. And if I look at the same thing again, I can see the port is now gone. You can also do the remove port as well. Just remove it the same way you add the ports. And that is the end of this lecture. Processes and resources.